Hello friends, we all welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. I have with me Ashu Jhangra sir, and the whole team BYJU'S Exam Prep Electrical Engineering is going to give you the most authentic live exam analysis for engineering services examination. Sir, how was the paper this year as we were discussing backstage?
Sir, with respect to power electrons and machine, I can tell you
Yes,
that the maximum questions are formula dependent and direct questions are
there.
So
if you compare in terms of the difficulty level from the previous year, sir, what has been your experience? Because I have seen that last year paper was little more on the difficult side if you compare it from the current present year question paper.
Because till now I have solved some power electronics and machines, sir. So not all the questions, but I have solved some 50%. So those questions are very easy and
formula-based
questions are there. So it's not that I think it's very simple questions they have asked.
Even if I talk about power system also, sir, we have seen that the direct statement-wise questions are there. If you have read the concept, for example, there was a question on bus type, so it was just a reasoning question. If you know the concept of buses, it is a reasoning question. So the question was bit on the easier side. So definitely cutoff is going to be very high.
Because in ESC सर वैसे भी अगर हम देखें तो पेपर जो है वो आपको जल्दी करना होता है, फास्ट करना होता है, तो क्वेश्चंस का जो लेवल होता है वो काफी लेस हो जाता है. मतलब ज्यादा हाई लेवल क्वेश्चंस का नहीं पूछा जाता है. तो ऑब्वियसली आपको सिंपल लेवल के क्वेश्चंस जो हैं वो मिलते हैं. मतलब कई सारे क्वेश्चंस तो ऐसे हैं सर जिनमें डायरेक्ट फॉर्मूला
ही लिख दिया है, ऑप्शन में लिख दिया है.
एग्जैक्टली.
बट सर कुछ क्वेश्चंस मैंने देखे पावर सिस्टम में थोड़े से ट्रिकी क्वेश्चन है. जैसे कोरोना के ऊपर एक क्वेश्चन आया है और उसमें कुछ खास इतना ज्यादा दिमाग नहीं लगाना था, लेकिन ऑप्शंस ऐसे मैचिंग थे जो आपको कंफ्यूज कर सकते थे. So friends, we'll be starting with a little analysis of the paper, that how was the examination, engineering services examination paper this year, and then we'll be starting with the solution of the questions. So
sir,
if we talk about the subject wise difficulty level and the weightage analysis, so as we have already reported that the question was little on the easier side. Formula based questions are there, factual questions are there, direct statement from the definition of various things. For example, if you talk about the stability, steady state stability, we are discussing a question, a direct, even you don't need to use your pen, directly you put the answer. That type of questions are there.
Similarly in power electronics में भी थायरिस्टर के कुछ क्वेश्चंस हैं, मतलब बिल्कुल डायरेक्ट क्वेश्चन पूछे गए हैं. बिल्कुल अगर फॉर्मूला याद है तो बहुत अच्छी बात है, आप डायरेक्ट कर लोगे, और अगर नहीं याद है तो फिर आपको डिफिकल्टी आएगी. तो बेसिकली बिल्कुल सीधे क्वेश्चंस आपसे पूछे गए हैं. तो इजी क्वेश्चंस का मतलब आप कह सकते हैं अभी तक. जी सर.
सर assertion रीजनिंग के भी क्वेश्चंस जो मैंने अभी तक देखे वो मुझे लग रहा है कि वो भी कुछ खास इतना डिफिकल्टी लेवल नहीं है.
Exactly. इवन मैंने मशीन का एक क्वेश्चन देखा था सर, तो उसमें बीएच कर्व के ऊपर एक क्वेश्चन आ रखा है रीजन एसोसिएशन का, तो वो भी काफी सिंपल क्वेश्चन है. द क्वेश्चन लेवल इज नॉट दैट मच डिफिकल्ट. So
guys, everybody who is live with me, just quickly share this session with your friends and colleagues, because we are going to provide you one of the most authentic solution as we have provided year on year, and this is one more time when we are providing you the live exam analysis for engineering services examination. So guys, just loop in your friends and colleagues so that more and more students are going to be benefited. Sir, I think you should start with the question so that the students will be But before that, yes, so let us talk about the weightage first. You should have a basic understanding of how was the weightage for different subjects. So if you talk about digital electronics, we got only one question, sir. Analog electronics 10 questions, electric circuits 9 questions, signal system 13, control system 13. Electromagnetic field, no question. It is a little surprising for me, because engineering services generally we get almost equal weightage to every subject. Maybe I think there is a mismatch, because EMFT questions sometimes it overlap with other subjects like network. Maybe there are mutual inductance related questions.
वैसे भी इलेक्ट्रोमैग्नेटिक फील्ड से डायरेक्ट क्वेश्चंस बनते हैं, तो वो पूछते ही हैं. I don't know why this time.
हो सकता है. We'll check it and get back to you again. And we have measurement, significant weightage. You see in GATE examination, I think only 1 or 2 questions were there, but you see in engineering services 13 significant weightage is given. Material science, good amount of questions, 10 questions. Sir, थोड़ा सा आप ये
माइक्रोप्रोसेसर का अगर आप देखें तो केवल एक ही क्वेश्चन आया है. जनरली माइक्रोप्रोसेसर भी अच्छा पूछा जाता है, बट माइक्रोप्रोसेसर एक ही पूछा गया. बेसिक इलेक्ट्रॉनिक्स इंजीनियरिंग में 10 क्वेश्चन पूछे गए हैं, एंड कम्युनिकेशन सिस्टम के भी 10 क्वेश्चन हैं. अगर आप कोर की बात करें, कंप्यूटर फंडामेंटल 11 क्वेश्चन है. कोर की अगर बात करें सर, कोर में देखिए 14, 12 एंड 13. मतलब ये अच्छा पूछा गया। मशीन्स के काफी क्वेश्चंस हैं, पावर इलेक्ट्रॉनिक्स के भी काफी क्वेश्चंस हैं, पावर सिस्टम के भी
अच्छे
काफी
खासे क्वेश्चंस हैं,
पूछे गए हैं। मैथ्स भी आपको इसमें आपको अच्छा खासा पूछा गया है।
यस यस
एग्जैक्टली
सर। ओवर टू यू। आई होप you will be starting with the questions and later on I will be joining you soon, so please start with the questions. So you are starting with the
power electronics.
Power electronics.
Okay guys, so don't forget to like this session and please share this session to the maximum. So चलिए start करते हैं with the power electronics. So power electronics was very easy and I have some 6-7 questions on power electronics. So obviously I have to come again for the remaining questions because अभी तक जो हमने जल्दी जल्दी जिन क्वेश्चंस को हम सोल्व कर पाए हैं उन्हीं क्वेश्चंस को हमने सोल्व किया है। तो फटाफट इनके देख लेते हैं कि क्या क्या हमारे पास क्वेश्चंस पूछे गए हैं। तो चलिए दोस्तों पावर इलेक्ट्रॉनिक्स के क्वेश्चंस को हम लोग देखते हैं, बट उससे पहले ये थोड़ा सा हमारा वेटेज है भी, ठीक है, सब्जेक्ट वाइज वेटेज जो है। तो आप देख सकते हो कि मशीन जो है वो 9% है, पावर इलेक्ट्रॉनिक्स 9% है, पावर सिस्टम 7% है, सिग्नल एंड सिस्टम भी 8%, मटेरियल साइंस 9%। तो इस तरह से जो है वो सब्जेक्ट डिस्ट्रीब्यूशन हमारा है। ओके और ये जो आप देख पा रहे हो ये लास्ट 3 साल का आप कंपैरिजन देख पा रहे हो कि किस किस तरह से कौन कौन से क्वेश्चंस पूछे गए लास्ट ईयर, कौन से सब्जेक्ट से कौन से क्वेश्चन पूछे गए हैं। जैसे कि अगर आप देखें तो इलेक्ट्रोमैग्नेटिज्म से, अगर आप देखिए इलेक्ट्रोमैग्नेटिक फील्ड से 2020 में 6 क्वेश्चन पूछे गए थे, 2021 में 2 और 22 में 2 और 23 में मैंने अभी आपको बता ही दिया है, ठीक है ना। एग्जैक्टली लुक एट द मटेरियल साइंस। मटेरियल साइंस काफी अच्छा पूछा जाता है, तो मटेरियल साइंस का काफी ज्यादा वेटेज है। सिमिलरली आप अगर आप बाकी सब्जेक्ट्स का देखें, जैसे कि आप पावर इलेक्ट्रॉनिक्स का देखिए, पावर इलेक्ट्रॉनिक्स का 13 इस बार भी आपका क्वेश्चन जो है वो 12-13 पूछे गए हैं। एंड एग्जैक्टली पावर सिस्टम भी आपका 13 क्वेश्चंस, दिस ईयर आल्सो 13 क्वेश्चंस पूछे गए हैं। सो काफी क्वेश्चंस जो हैं आपके मतलब कोर्स से काफी क्वेश्चंस आपसे पूछे गए हैं दोस्तों। तो चलिए स्टार्ट करते हैं। एंड यहाँ पे मैं पावर इलेक्ट्रॉनिक्स से पहले स्टार्ट कर रहा हूं। तो ये मेरे पास एक क्वेश्चन है 109 क्वेश्चन नंबर। सो इस क्वेश्चन में कंसीडरिंग द स्टैंडर्ड नोटेशन रिवर्स रिकवरी टाइम ऑफ पावर डायोड, आपसे रिवर्स रिकवरी टाइम के बारे में पूछ रहा है। तो चलिए दोस्तों स्टार्ट करते हैं सिलसिला क्वेश्चंस को सोल्व करने का। हाँ, तो आपसे पूछा गया है कि रिवर्स रिकवरी टाइम क्या होता है। तो आपको पता होगा कि डायोड का अगर आप देखें तो करंट का जो ग्राफ होता है वो कुछ इस तरह का होता है, ठीक है, कुछ इस तरह का होता है। और यहाँ पे जो रिवर्स रिकवरी टाइम है, हम ये जो टाइम लेते हैं इसको हम TRR बोलते हैं, रिवर्स रिकवरी टाइम। तो इसका अगर आपको डायरेक्ट फॉर्मूला याद है तो आप इजीली कर सकते हो। अदरवाइज आप क्या कर सकते हो, सबसे पहले देखिए जो रिवर्स रिकवरी जो QR है, तो चार्ज स्टोर था जिसको आपने जब ये वापस रिटर्न होता है तो ये हमारा QR चार्ज होता है। और QR की जो वैल्यू होती है दोस्तों वो हम निकाल सकते हैं इसको ट्रायंगल मान के, ठीक है। इस पीक वैल्यू को मैं IRM बोल देता हूं, ठीक है, IRM बोल देता हूं। तो ये बनेगा 1/2 इंटू ये हाइट IRM, ठीक है, और TRR रिवर्स रिकवरी टाइम। तो यहां से जो मेरा रिवर्स रिकवरी टाइम आएगा वो आएगा 2 टाइम्स ऑफ QR डिवाइड बाई IRM, सही है। अब अपने को जो IRM है उसकी वैल्यू निकालनी है। तो IRM की कैसे वैल्यू निकालें, अगर मुझे इसका स्लोप पता चल जाए di/dt, तो जो भी इसका स्लोप है di/dt इनटू ये जो टाइम है, ये वाला जो टाइम है इससे मल्टीप्लाई कर देता हूं। और ये टाइम अप्रोक्सीमेटली जो है वो TRR ही होता है दोस्तों। तो मल्टीप्लाई बाय TRR, ठीक है, ये मेरा क्या बन जाएगा, ये बन जाएगा IRM। ओके, सो IRM की वैल्यू अगर मैं पुट कर दूंगा यहाँ पे तो आप देख सकते हो जो फॉर्मूला जो हमारे पास बनेगा, मतलब यहाँ से TRR की जो वैल्यू आएगी, अगर आप IRM की ये वैल्यू पुट करते हो तो आंसर इज आगरा। TRR इज इक्वल टू 2QR डिवाइड बाई di/dt, सही है। तो आंसर इज आगरा। ओके, लेट्स मूव टू द नेक्स्ट क्वेश्चन। नेक्स्ट क्वेश्चन इज अगेन वेरी सिंपल। नेक्स्ट क्वेश्चन, वेट अ मिनट, मैं इसको नेक्स्ट स्लाइड की तरफ मैं लेके चलता हूँ, 1 मिनट रुकिए भाई। ओके, हाँ, तो चलिएगा दोस्तों नेक्स्ट क्वेश्चन की तरफ चलते हैं। 1 मिनट, हाँ, नेक्स्ट स्लाइड देखिए। तो ये क्वेश्चन है ओवरड्राइव फैक्टर ऑफ ए पावर ट्रांजिस्टर। अब अगर ये याद है तो याद है, ओवरड्राइव फैक्टर बेसिकली वो होता है कि सैचुरेशन में जब कोई ट्रांजिस्टर जाता है तो कितना डीप सैचुरेशन में है, तो बेसिकली आप उस चीज को बोल सकते हो ओवरड्राइव फैक्टर। तो इसमें जो फॉर्मूला है वो हमारा होता है बेस करंट डिवाइड बाई बेस करंट रिक्वायर्ड टू ऑपरेट इन सैचुरेशन, ठीक है, एक्चुअल बेस करंट डिवाइड बाई जो मिनिमम रिक्वायरमेंट होती है सैचुरेशन में जाने के लिए, वो वाला। तो ये जो रेशियो होता है ये आपका क्या होगा, आपका ओवरड्राइव फैक्टर होगा। तो ये बहुत आसान क्वेश्चन था और इजीली आप इस क्वेश्चन को सोल्व कर सकते थे। तो आंसर जो आएगा वो आएगा बॉम्बे, ठीक है। चलिए दोस्तों नेक्स्ट क्वेश्चन की तरफ मूव करते हैं। तो इसमें तो डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन आपसे पूछ लिया गया, ठीक है ना। नेक्स्ट आइए, नेक्स्ट है मेरे पास when the amplitude of gate pulse to the thyristor is increased। ये कह रहा है जब मैं एम्पलीट्यूड गेट पल्स को बढ़ाऊंगा तो क्या फर्क पड़ेगा डिले टाइम पे और राइज टाइम पे, ये क्वेश्चन पूछा गया है। तो सुनिए दोस्तों, डिले टाइम जो होता है, डिले टाइम कौन सा टाइम होता है, अगर आपने डिले टाइम का एक्सप्रेशन देखा हो तो जब आपका जो गेट पल्स अप्लाई करते हो तो उससे जो एनोड करंट है वो मेरा बढ़ना स्टार्ट करता है। तो एनोड करंट जो बढ़ेगा, जरा देखिए, जो एनोड करंट आपका इंक्रीज होगा तो वो कुछ इस तरह का मेरा एनोड करंट मेरा इंक्रीज होता है, ठीक है। तो डिले टाइम जो होता है, डिले टाइम आपका जनरली जब हम गेट पल्स को हम डालते हैं और उससे जब गेट पल्स को बढ़ाते हैं तो डिले टाइम हमारा रिड्यूस होने की टेंडेंसी दिखाता है। बेसिकली एक स्टेट सीधी सीधी लाइन है कि डिले टाइम डिक्रीजेस व्हेन द गेट पल्स इंक्रीजेस बिकॉज द नंबर ऑफ चार्जेस जो आप डाल रहे हो, ये जो डिले टाइम है आपका, ये शुरुआत वाला जो टाइम होता है ये डिले टाइम होता है ये। तो कुल मिला के यहाँ पे आपका जो करंट है वो काफी एक तरह से मतलब ये जो राइज है इसका, जितनी देर में ये राइज कर रहा है, ये जो राइजिंग टाइम है ये आपका रिड्यूस हो जाएगा अगर आप क्या करोगे बताओ, गेट पल्स को बढ़ा दोगे। कॉमन सेंस है इसमें, क्योंकि नंबर ऑफ चार्ज कैरियर बढ़ जाएंगे आपके गेट पल्स से और डिले टाइम है वो थोड़ा सा रिड्यूस हो जाएगा। तो सबसे पहले तो डिले टाइम डिक्रीज होगा। राइज टाइम पे क्या फर्क पड़ेगा? राइज टाइम पे कोई फर्क नहीं पड़ेगा। क्यों नहीं पड़ेगा कोई भी फर्क? क्योंकि राइज टाइम जो होता है वो एनोड करंट पे डिपेंड करता है, लोड पे डिपेंड करता है। तो इसलिए आप राइज टाइम, जनरली आप ये भी कह सकते थे कि राइज टाइम जो है वो हाई एंड स्टीप गेट पल्स से रिड्यूस होता है, बट हाउएवर इट डिपेंड्स ऑन द टाइप ऑफ लोड, ठीक है, लोड किस तरह का है, ठीक है। तो लोड पे भी डिपेंड करेगा, और लोड क्योंकि इसने बता नहीं रखा, तो लोड का नेचर अगर आपको नहीं पता है तो इसका मतलब हम मान के चलेंगे कि मेरा जो राइज टाइम है वो मेरा कांस्टेंट रहेगा। तो आपको क्या आंसर देना है बताइए इसमें? बोथ डिले टाइम एंड राइज टाइम वुड इंक्रीज, ये गलत हो गया। द डिले टाइम वुड डिक्रीज, ये तो सही है, बट द राइज टाइम वुड इंक्रीज, ये सही नहीं है भाई। द डिले टाइम वुड डिक्रीज बट द राइज टाइम रिमेन्स अनअफेक्टेड। तो मेरे हिसाब से ये आंसर करेक्ट होना चाहिए। राइज टाइम मेरा क्या रहना चाहिए? अनअफेक्टेड रहना चाहिए। तो आंसर इज कैलकाटा, ठीक है। तो ध्यान रखिएगा राइज टाइम जो है वो लोड पे डिपेंड करता है। चलिए दोस्तों अगले क्वेश्चन की तरफ मूव करते हैं। नेक्स्ट क्वेश्चन जरा देखिए। तो नेक्स्ट क्वेश्चन जो है मेरे पास, नेक्स्ट स्लाइड पे आते हैं। हाँ जी, जरा नेक्स्ट क्वेश्चन जरा देखिए क्या है दोस्तों। ये नेक्स्ट क्वेश्चन में क्या पूछा है? ए सिंगल फेज फुल वेव ब्रिज रेक्टिफायर इज फेड फ्रॉम 220 वोल्ट 50 हर्ट्ज सप्लाई। तो मेरे पास एक ब्रिज रेक्टिफायर है, तो मैं डायोड सर्किट बना देता हूं, ठीक है। कुछ इस तरह का सर्किट है दोस्तों मेरे पास, ब्रिज रेक्टिफायर है। तो मैंने यहां पे डायोड सर्किट बना दिया और मेरी जो सप्लाई है वो 220 वोल्ट है, 220 वोल्ट सप्लाई दे रखी है, ओके। तो इस तरह का सर्किट है, सिंगल फेज फुल वेव ब्रिज रेक्टिफायर सर्किट फेड फ्रॉम 220 वोल्ट 50 हर्ट्ज सप्लाई। इट कंसिस्ट ऑफ 4 डायोड्स, ए लोड रेजिस्टेंस ऑफ 20 ओम एंड ए वेरी लार्ज इंडक्टेंस सो दैट द लोड करंट रिमेन कांस्टेंट। इसका मतलब ये कह रहा है कि लोड में हमने एक रेजिस्टेंस लगा रखा है और एक काफी लार्ज इंडक्टेंस लगा हुआ है, ठीक है। रेजिस्टेंस है मेरा 20 ओम का और एल जो है वो मेरा वेरी हाई है, एल मेरा काफी हाई है दोस्तों। और ये जो करंट है ये मेरा कांस्टेंट है, ये मेरा कांस्टेंट करंट है, ठीक है भाई, ये मेरा कांस्टेंट करंट है। तो क्या कर रहा है ये? so that the load current is constant, what is the average और DC output voltage? तो ये तो बहुत आसान हो गया भाई, कंटीन्यूअस कंडक्शन आएगा, आपसे पूछ रहा है एवरेज आउटपुट वोल्टेज क्या आएगी। तो आप क्या कर सकते हो बताइए, आप जो है आउटपुट वोल्टेज की वेव शेप को प्लॉट कर सकते हो। सो दिस विल बी द आउटपुट वोल्टेज वेव शेप एंड this value will be Vm and Vm value is 220 root 2. Vm value is 220 root 2. Now the average value, what is the average value of this output? Average value will be equal to 2 Vm by pi, okay. So the answer will be equal to 2 into the Vm value is 220 root 2 by pi, okay. So this will be my average output voltage and its value come out to be 198.165, okay. So it's very simple, you can easily solve this question. Let's move to the next question guys. Let's move to the next question. So the next question is a single phase full wave controlled bridge rectifier. Now this time it's a controlled bridge rectifier with a source inductance. So now it's a controlled bridge rectifier. So quickly you can draw the diagram. Okay, it's a single phase controlled bridge rectifier. So this is the rectifier, okay. Now in the question it is given that the load is RL, okay, the load is RL, the load is RL. Now the output voltage during overlap, is equal to, during overlap, all the thyristors will conduct. If all the thyristors will conduct, then the output voltage will be 0. You can see that this is sorted, and this is also sorted. So the output voltage will be 0. So the answer is Calcutta. Okay. So the output voltage during overlapping interval will be 0. I hope it is clear. Let's move to the next question, guys. Let's move to the next question, and the next question is from power electronics. So again, I have to solve this question. This question is not yet solved, so I'm trying to solve this question, and then after the next, in the next session, I'll take this. Because I have to come again, okay, with machines and power electrons, because right now I have solved only 5 to 6 questions. So now I'm going to solve this question, but maybe after some time. Let's come to the next thing. When a separately excited DC motor, let's try to solve this question. When a separately excited DC motor is to be controlled from a 3-phase source for operation of first quadrant only. Now, you need operation in first quadrant only, okay? You need operation in first quadrant. It means the output voltage and current has to be positive always, okay? So, and the motor is RLE. Separately excited motor can be shown in RLE type of, the load can be of RLE type, okay? Now, which one of the following converter is used? Which converter can be used? We have a 3-phase converter. Now, 3-phase dual converter, no, it's not required. Why? Because 3-phase dual converter is required when you need 4-quadrant operation. That's why this is not required. 3-phase semi-converter, yes. In 3-phase semi-converter, you can see that the voltage will always be positive. And current will also be positive, okay? So answer is 3-phase semi-converter. Now, 3-phase full converter. In 3-phase full converter, voltage can be negative. Current will always positive, but voltage can be negative. So it's a 2-quadrant converter. So we don't require that. We require only 1 quadrant. So that's why semi-converter is used. 3-phase half-wave converter. Again, I told you that 3-phase half-wave converter is also used. But in 3-phase half-wave converter, the average voltage will get reduced. So that's why we'll go with the 3-phase semi-converter. Okay, I hope it is clear. Let's move to the next question, guys. Let's move to the next question. Okay, so wait a minute. Okay, so from this point onward, network theory, sir. So network theory will be discussed, and sir will discuss network theory with you. So after some time, I'll come again with the machine questions and power electronics questions. Okay, so enjoy with the sir, and try to solve network questions also. Okay, so sir.
Hello everyone. So कैसा गया आप लोगों का एग्जाम? If you have given the exam today, then tell me how was your exam going on? So बच्चों, I'm going to solve few questions of electrical circuits, or you can say a network theory. Okay, let me see the questions. Wait a sec. So we are going to solve few questions from a network theory, and if I'm not wrong, approximately 9 questions has come from a network theory. So we are going to discuss each and every question from there. So this is the first question, और सिंपल क्वेश्चन है. अगर मैं बात करूं प्रीवियस ईयर से बात करें या फिर कोई भी दूसरा एग्जाम उठा के देख ले, नेटवर्क थ्योरी के क्वेश्चंस काफी सिंपल आए हैं. So ये फर्स्ट क्वेश्चन आपकी स्क्रीन पे आपको दिख रहा है. The question is, the current waveform is shown in a figure below. What is the average value of the time interval, average value over the time interval from 1 to 7? So here you can see, सिंपल सा आपको यहाँ पे कर्व दिया हुआ है ना, एक सिंपल सी वेवफॉर्म दे रखी है. यहाँ पर आपसे एवरेज वैल्यू पूछ रहे हैं, तो जल्दी से बताओ इसका आपका आंसर क्या आया है. ठीक है, सिंपल अगर मैं बात करूं तो एवरेज का फॉर्मूला क्या होता है बच्चों? एवरेज इज इक्वल टू एरिया डिवाइड बाय टाइम पीरियड. ओके, एरिया डिवाइड बाय टाइम पीरियड. ओके, नाउ ये वाला फॉर्मूला हम इसलिए यूज कर रहे हैं बिकॉज हमारे पास स्क्वायर वेवफॉर्म दे रखी है, और स्क्वायर वेवफॉर्म का एरिया हम इजीली फाइंड कर सकते हैं. सो अगर मैं बात करूं फ्रॉम 1 to 3 इंटरवल, तो यहाँ पे आपके पास एरिया कितना होगा? 1.5 मल्टीप्लाई बाय 3 प्लस यहाँ पर मैग्नीट्यूड कितना है? -2. सो -2 मल्टीप्लाई बाय 5 - 3 2 प्लस लास्ट इंटरवल की बात करें, इट विल बी 1 मल्टीप्लाई बाय 1 डिवाइड बाय टाइम पीरियड. टाइम पीरियड मींस 7 - 1 = 6. सो अगर मैं इसको सॉल्व करूं 1.5, अच्छा माय फॉल्ट यहाँ पर 3 नहीं आएगा, 2 आएगा, सॉरी, मल्टीप्लाई बाय 2. क्यों? बिकॉज 3 - 1 हो रहा है, 3 - 1 विल बी 2 here. So कितना हो गया? 3 - 4 + 1 डिवाइड बाय 6, it comes out to be 0. So the answer is ऑप्शन सी एंड इट विल बी अ जीरो आंसर. सो अब देख रहे हो काफी सिंपल क्वेश्चन था, राइट? सो लेट्स गो टू अ नेक्स्ट क्वेश्चन. वेट अ सेक. नेक्स्ट अगेन सिंपल क्वेश्चन है, सिंपल क्वेश्चन, बच्चों वाला क्वेश्चन. क्वेश्चन क्या है? व्हाट आर द अननोन करेंट्स I5 एंड आई गेस ये लिखा हुआ है I3. ओके, दिस इज I3. What are the unknown currents I5 and I3 respectively for the circuit shown in a figure? So हमें इस टाइप का एक सर्किट दिया हुआ है. सिंपल से अगर आप देखोगे तो ये नोड A है, दिस इज अ नोड B एंड दिस इज अ नोड C एंड डिफरेंट करंट डिस्ट्रीब्यूशन दिया हुआ है. सो वी जस्ट हैव टू अप्लाई द KCL एंड आंसर आपके सामने है. कैसे? तो अगर मैं नोड B पर देखते हैं सबसे पहले, इफ आई अप्लाई द KCL एट नोड B. सो अगर नोड B पर KCL लगाऊं तो आप देख रहे हो I1 एंटर कर रहा है एंड I2 एंड I3 आर लीविंग. तो सिंपल, I1 is equal to I2 plus I3. What is I1? It is 5. What is I2? It is 4 plus I3. So I3 comes out to be 1 ampere. है ना? सिंपल सा कैलकुलेशन है बच्चों, कुछ भी नहीं है. So I3 comes out to be 1 ampere. अब ध्यान से देखो 1 एम्पियर का यहां पर I3 में ओनली ऑप्शन ए आपके सामने दिख रहा है, तो आंसर इज ऑप्शन ए. एंड अगर आपको I5 में निकालना है तो आप नोड ए पर KCL लगा सकते हो. अगर मैं KCL अप्लाई करता हूं, KCL एट नोड ए, है ना? सो इट विल बी IS इज इक्वल टू I1 प्लस I4 प्लस I5. IS कितना है? 10 दिया हुआ है. I1 आई गेस 5 है, I4 3 है and I5 we need to find out. So I5 comes out to be I5 comes out to be 2 ampere. I5 comes out to be 2 ampere. Okay, so option A is the right answer. Next. नेक्स्ट सिंपल क्वेश्चन है भी. हाँ, इसमें इस क्वेश्चन में आप मैं बोल सकता हूँ आपकी कैलकुलेशन थोड़ी सी ज्यादा होगी, अदरवाइज क्वेश्चन सिंपल. पयाश, गुड इवनिंग बच्चे. एंड बच्चों शेयर द सेशन अमंग योर फ्रेंड्स. ओके, सुप्रिया रिफ्रेश योर स्क्रीन इफ वी आर नॉट विजिबल टू यू. ओके, सो क्वेश्चन सिंपल है. क्वेश्चन में एक बार मैं डायग्राम आपके लिए यहाँ पर ड्रॉ कर देता हूँ. मे बी आपको डायग्राम समझने में थोड़ी प्रॉब्लम हो, तो मैं जल्दी से यहाँ पर एक डायग्राम आपके सामने ड्रॉ कर देता हूँ. ओके, बच्चे ने पेपर शेयर किया हमारे साथ, तो इट मे हैपन दैट यू आर नॉट एबल टू अंडरस्टैंड हियर. तो जल्दी से डायग्राम ड्रॉ करते हैं. दिस विल बी 10 वोल्ट, दिस विल बी 5 ओम, इट इज 20 वोल्ट. ये 4 ओम दिया हुआ है, 8 ओम, 4 ओम, इट इज 10 ओम, इट इज 25 एंड 20, 25 ओम एंड 20 ओम. तो इस क्वेश्चन में क्या है, आपको निकालना है व्हाट इज द करंट डिलीवर्ड बाय द 10 वोल्ट सोर्स. ओके, 10 वोल्ट सोर्स कितना करंट डिलीवर कर रहा है ये मुझे फाइंड करना है. मींस आई नीड टू फाइंड आउट द करंट पास थ्रू 10 वोल्ट सोर्स. वेट अ सेक. ओके, दिस करंट. ओके, सो हम यहाँ पे क्या करते हैं, सिंपल मैश एनालिसिस यूज करूं मैं यहाँ पे. सो I1, I2, I3 ये तीन मैंने करंट यहाँ पर एज्यूम कर लिया. I1, I2, I3. साई प्रकाश 0. आई गेस आप पिछले क्वेश्चन का आंसर बता रहे हो 0, है ना? हमने एक क्वेश्चन करा था. सो यहाँ पर अगर हम सॉल्व करें, सबसे पहले मैं लूप 1 ले लूं, इसको लूप 2 ले लिया, इसको लूप 3 ले लिया. सो इफ आई अप्लाई द KVL इन लूप 1, सो अगर लूप 1 में KVL अप्लाई करें, इट विल बी 8 टाइम्स ऑफ I1 माइनस I2 प्लस 5 टाइम्स ऑफ I1 प्लस 20 I1 माइनस I3 इक्वल टू 10 वोल्ट. राइट, सो इसको अगर मैं सॉल्व करता हूँ तो 8 प्लस 5 13 प्लस 20 33 आ रहा है. आई गेस चेक कर लूँ, 28 प्लस 5 33. ओके, 33 I1 माइनस 8 I2 माइनस 8 I2, देन इट विल बी प्लस 20 I3 इक्वल टू 10. सो दिस कम्स आउट टू बी द इक्वेशन नंबर 1. ये क्या हो गया मेरे पास, इक्वेशन नंबर 1 हो गया. राइट, नाउ बाकी दो लूप में आप इक्वेशन बना सकते हो इक्वेशन नंबर 2 में. सो अगर मैं KVL लिखूं इन इक्वेशन नंबर 2, KVL in equation number 2, it will be 4 times 4 plus 10, 14 plus 8, 18 plus 4, 22. It will be 22 times of I2 and it will be minus 8 times of I1 minus 10 times of I3 comes out to be 20. This comes out to be question number 2, है ना. सिंपल केवीएल लगाना है. हाँ, यहाँ पे जब आप इसको सॉल्व करोगे तो हो सकता है ये कैलकुलेशन थोड़ी लेंदी हो जाए, तो इसको ध्यान से सॉल्व करना है एग्जाम के अंदर. एंड फाइनली अगर मैं थर्ड लूप में केवीएल लगाऊं, केवीएल इन लूप थर्ड, इट विल बी 10 plus 25 35, 35 plus 20 55. It comes out to be 55 I3 minus 10 I2 minus 20 I1. Okay, minus 10 I2 minus 20 I1 comes out to be 0. Equation number 3. Now after solving, अगर आप सॉल्व करोगे 1, 2nd एंड 3rd इक्वेशन आप सॉल्व करते हो तो I1 कम्स आउट टू बी 0.532 एम्पियर, जो कि हमें फाइंड करना है. वी हैव टू फाइंड आउट द करंट डिलीवर्ड बाय द 10 वोल्ट सोर्स. वो क्या है मेरे पास? I1. सो ऑप्शन डी इज द राइट आंसर. सो यहाँ पर आंसर कितना आ रहा है? ऑप्शन डी. ठीक है. सो नेटवर्क्स में जितने क्वेश्चन आया, अप्रोक्सीमेटली 9 क्वेश्चन आया मेरे हिसाब से. सो उसमें से बस यही क्वेश्चन है जिसमें आपको थोड़ा सा न्यूमेरिकल में ध्यान रखना है, क्योंकि इक्वेशन सॉल्व करनी है. सो इट मे हैपन कि आपके इक्वेशन थोड़ा बहुत रॉन्ग हो सके, बट अगर आप ध्यान से सॉल्व करोगे तो यू विल गेट द आंसर ऑप्शन डी. ओके, नेक्स्ट. अच्छा, ओके, नाउ वी विल सॉल्व दिस क्वेश्चन. सिंपल एवी. In the following circuit shown in a figure has a voltage source and a dependent source. What is the Thevenin's equivalent resistor at terminal AB? तो सबसे पहले आप देख रहे हो कि यहाँ पर क्या है मेरे पास? डिपेंडेंट सोर्स है. Whenever we have a dependent source, we have to use the test source method. Okay? So here, what we are going to do? We have to use the test source method. So if we are using a test source method here, उसमें सबसे पहले क्या होता है? डिपेंडेंट सोर्स आपके क्या हो जाएंगे? शॉर्ट सर्किट. ओके, डिपेंडेंट सोर्स, डिपेंडेंट वोल्टेज सोर्स क्या हो गया? शॉर्ट सर्किट. इंडिपेंडेंट सोर्स क्या हो गया? शॉर्ट सर्किट. कभी भी डिपेंडेंट सोर्स को आपको रिमूव नहीं करना है. ओके, एंड हियर वी हैव टू अप्लाई अ टेस्ट सोर्स. तो आई एम गोइंग टू अप्लाई द वोल्टेज सोर्स हियर ऑफ 1 volt एज अ टेस्ट सोर्स, एंड आई विल फाइंड आउट द वैल्यू ऑफ स्मॉल आई. This is actually I1. This is actually capital I. It is 2000 ohm. ये मेरे पास हो गया 200 ohm. Okay. Now we have to find out a small I. Once we find out a small I, then what will be the RTH? RTH will be 1 divided by small I, right? So what we have to do? अब आप देख रहे हो ये वोल्टेज सोर्स आपके 200 ohm के पैरेलल लगा हुआ है, right? 2000 ohm के पैरेलल भी लगा हुआ है. तो फर्स्ट ऑफ ऑल आई कैन फाइंड आउट द वैल्यू ऑफ कैपिटल आई. ध्यान रखना, प्लस माइनस, बट अकॉर्डिंग टू दिस करंट आई द पोलैरिटी इज प्लस माइनस. सो यहां पर माइनस साइन आएगा बिकॉज आपकी पोलैरिटी रिवर्स्ड है. ध्यान रखना इस बात को, अदरवाइज क्वेश्चन होंगे. ठीक है. सो कैपिटल आई कितना हो गया? -1/2000. और I1 कितना हो गया? बिकॉज ये भी आपकी पैरेलल ब्रांच है ना. तो बच्चों I1 कितना हो गया? 1/200. ओके, सो इसको मैं नोड एक्स ले लेता हूं. ठीक है. तो अप्लाई KCL एट एक्स. तो अगर मैं इसको नोड एक्स ले लूं तो इट विल बी, आप देख रहे हो कैपिटल आई और 9i एंटर कर रहा है. I प्लस 9i प्लस स्मॉल आई एंटर्स, एंड I1 क्या कर रहा है? आपके पास लीव कर रहा है. ठीक है. सो कितना हो गया? 10 टाइम्स ऑफ कैपिटल आई. कैपिटल आई कितना है? -1/2000. और स्मॉल आई कितना है? स्मॉल आई मुझे फाइंड करना है. ठीक है. और यहां पर I1 कितना है? 1/200. ओके. सो इसको अगर मैं सॉल्व करता हूं, इट कम्स आउट टू बी I इक्वल टू 1/100. आई कितना आ रहा है? 1/100 आ रहा है. What is RTH? 1 divided by small I. So it comes out to be 100 ohms. So RTH कितना आ गया? 100 ohms. तो ऑप्शन सी इज द राइट आंसर. राइट, सिंपल क्वेश्चन था, है ना. इस टाइप के क्वेश्चन आपको हमने क्लास में भी काफी बार कराया है. अगर आप फ्री सेशंस देखोगे हमारी ऐप पर, वहां पर भी काफी बार हुए हैं. प्लस यूट्यूब की क्लासेस पर भी ये क्वेश्चन काफी बार हो चुके हैं. तो सिंपल क्वेश्चन है. आई होप इसमें कोई मिस्टेक नहीं हुई होगी आप लोगों की, लेकिन स्टिल आप अपने भी आंसर शेयर कर सकते हो बच्चों. नेक्स्ट. ओके, So question है, an experimental circuit as shown in the figure below has the variable resistor RL which is adjusted to the value of load resistor as 10 ohm. What is the maximum load power? अब क्वेश्चन ध्यान से देखना, क्वेश्चन में लास्ट में लाइन यूज की गई है मैक्सिमम लोड पावर, लेकिन अगर आपको पता होगा कि अगर आप इस क्वेश्चन में मैक्सिमम पावर ट्रांसफर थ्योरम लगाओगे दैट विल बी रॉन्ग. क्यों? बिकॉज उन्होंने साफ साफ इस क्वेश्चन में बोला हुआ है कि जो लोड रेसिस्टर है उसको फिक्स कर दिया है 10 ओम के इक्वल, लिखा है ना. तो जो लोड रेसिस्टर की वैल्यू है वो 10 ओम के अक्रॉस 10 ओम फिक्स हो गई है. और जो मैक्सिमम पावर थ्योरम होती है दैट कैन ओनली बी अप्लाइड फॉर अ वेरिएबल लोड, नॉट फॉर अ फिक्स्ड और अ कांस्टेंट लोड. तो यहां पर आपको क्या है, सिंपल पावर फाइंड करनी है, वेरिएबल पावर निकालने की जरूरत नहीं है. ठीक है. सो यहां पर RL 10 है, तो वी कैन फाइंड आउट द वैल्यू ऑफ I कितना होगा, VG डिवाइड बाय RS प्लस RL. So 10 डिवाइड बाय 30 प्लस 10 1/4 एम्पियर है ना. पावर कितनी होगी, सिंपल I स्क्वायर RL, तो 1/4 होल स्क्वायर multiply by 10 it comes out to be 0.625 watt. 0.625 watt. अच्छा, क्वेश्चन में क्या बोला, मिलीवॉट में, सो इट विल बी 625 मिलीवॉट. तो ऑप्शन डी इज द राइट आंसर. ऑप्शन डी क्या होगा, राइट आंसर होगा. समझे? कोई डाउट है? सिंपल. भाई याद रखना, मैक्सिमम पावर थ्योरम मत लगा देना, बिकॉज लोड रेसिस्टर को बोला है कि उसका जो वैल्यू है वो फिक्स्ड है, and maximum power theorem is only applicable for variable load. ठीक है, simple. Next, again simple question from the concept of transient. कुछ नहीं है इस क्वेश्चन में. क्वेश्चन में क्या बोला है, in the circuit of the figure we have seen that ये जो है आपके पास 100 वोल्ट का है. according to question ये क्या है, पास 100 वोल्ट का है and the resistance is 10 kilo ohm, capacitance is 0.0005 microfarad. In how much time can the capacitor voltage is discharged to 5 volt when the switch is turned to position 3? तो क्वेश्चन में सिंपली ये बोला है कि ये स्विच आपका पोजीशन 1 पर होगा, और जब ये स्विच पोजीशन 1 पर होगा तो कैपेसिटर वोल्टेज के अक्रॉस बैटरी का वोल्टेज आ जाएगा. तो मैं बोल सकता हूं इनिशियल वोल्टेज अक्रॉस कैपेसिटर कितना होगा, E के इक्वल होगा. सॉरी, किसके इक्वल होगा बच्चा, E के इक्वल होगा, राइट. It will be equal to E. Now according to question that E is actually 100 volt, है ना. हाँ, तो now जब ये पर्टिकुलर स्विच आपका थर्ड पोजीशन पे आएगा तो आपका कैपेसिटर डिस्चार्ज होना स्टार्ट हो जाएगा. तो जब कैपेसिटर डिस्चार्ज होगा उसकी डिस्चार्जिंग इक्वेशन क्या होती है, इट विल बी इक्वल टू Vc0 प्लस e रेज टू पावर माइनस t बाय टाउ. नाउ व्हाट इज टाउ, टाउ इज इक्वल टू R मल्टीप्लाई बाय C. R कितना है यहाँ पे, R 10 किलो ओम है. 10 इंटू 10 रेज टू पावर 3 इंटू 0.005 आई गेस 2 बार 0, हाँ, माइक्रो सेकेंड, माइक्रो फराड है तो माइक्रो सेकेंड हो गया ये. सो इट कम्स आउट टू बी 50 माइक्रो सेकेंड. इट कम्स आउट टू बी 50 माइक्रो सेकेंड, है ना. दिस इज माई टाइम कॉन्स्टेंट. अब सिंपली इसको यहां पर पुट करना है. सो कैपेसिटर वोल्टेज कम्स आउट टू बी बच्चों यहां पर ये 50 माइक्रो सेकेंड है. कैपेसिटर वोल्टेज कम्स आउट टू बी 100 e रेज टू पावर माइनस t बाय 50. ओके, सिंपल. नाउ क्वेश्चन के अकॉर्डिंग क्या बोला है कि कब ये डिस्चार्ज टू 5 वोल्ट होगा. सो मैं यहां पे क्या करता हूं, इस चीज को कैपेसिटर वोल्टेज को हम इक्वल कर देते हैं 5 वोल्ट के. तो सिंपलीफाई से 100 e रेज टू पावर माइनस t बाय 50 इज इक्वल टू 5. ना अब आप जब इसे सॉल्व करोगे ना तो टाइम आएगा मेरे पास 150 माइक्रो सेकेंड, मीन्स ऑप्शन डी. एंड यस, इसको आपको ध्यान से सॉल्व करना पड़ेगा. और जैसे कि आपको क्लास में बताया गया था कि कुछ एक्सपोनेंशियल की ना पावर की वैल्यूज याद कर लिया करो कि e की पावर -1, -2 और -3 क्या है. अगर आपको e की पावर -3 याद है तो आप विदाउट यूजिंग अ कैलकुलेटर ये पर्टिकुलर क्वेश्चन सॉल्व कर सकते हो, है ना. ऑप्शंस को ऐसे उठा के ऑप्शंस के में पुट करो, आंसर आएगा. ठीक है. और वैसे भी आप देखो ऑप्शंस का यूज कैसे करना है. आपके पास टाइम कांस्टेंट माइक्रो सेकंड में है तो टाइम भी आपका माइक्रो सेकेंड्स में ही आने वाला है। तो ऑप्शन बी और ऑप्शन सी तो वैसे ही रॉन्ग हो गया। अब अगर आप 50 माइक्रो सेकेंड रखोगे तो 50 माइक्रो सेकेंड क्या है, टाइम कांस्टेंट है, और टाइम कांस्टेंट पर आपकी वैल्यू क्या होती है डिस्चार्जिंग के केस में 37% ऑफ इनिशियल वैल्यू, ठीक है। बट ये क्या है आपकी 5 वोल्ट है जो कि बहुत कम है 37% से, 95% हो चुकी है। तो इसका मतलब ऑप्शन ए भी आंसर नहीं हो सकता। सो विदाउट गोइंग थ्रू होल कैलकुलेशन आप डायरेक्टली ऑप्शन से ही आंसर निकाल सकते थे, ऑप्शन डी आपका आंसर होता। नेक्स्ट, so a Y connected generator is to be designed to supply a 20 kV three-phase line and supply a line current of 10 ampere at a lagging power factor of 0.8. How much reactive power should be supplied? तो reactive power का फॉर्मूला क्या होता है, √3 times of load voltage, line voltage and sin phi। याद रखना ये आपके RMS में होते हैं, ठीक है। So cos phi we have given 0.8, तो यहां से साइन फाई कितना आ जाएगा मेरे पास 0.6, तो रिएक्टिव पावर कितनी होगी मेरे पास √3 20 मल्टीप्लाई बाय 10 मल्टीप्लाई बाय 0.6, ठीक है। तो 20 केवी में है तो यहाँ पर आंसर भी केवी में आएगा। तो इसको आप सॉल्व करोगे इट विल बी 207.84 kVAR, ओके। तो ऑप्शन बी इज द राइट आंसर, ओके। आई गेस 2 क्वेश्चन और है, देखता हूं यहां पर लगे हैं या नहीं। हाँ, देयर इज वन क्वेश्चन वी कैन सॉल्व हियर, ओके। देयर इज वन क्वेश्चन वी कैन सॉल्व हियर, ओके। तो क्वेश्चन क्या सिंपल है, अ सर्किट कंपोज्ड विद सीरीज कॉम्बिनेशन ऑफ साइनसॉइडल वोल्टेज सोर्स ऑफ 3 cos 100t + 3 डिग्री, अब 500 ओम रेसिस्टर, ओके। मैं यहाँ पे लिख देता हूँ, आपको शायद डेटा यहाँ पे साफ नहीं दिख रहा होगा, मैं यहाँ लिख देता हूँ कि यहाँ पर जो रेसिस्टेंस दिया है वो दिया है 500 ओम, इंडक्टेंस दिया है मेरे पास सीरीज में, ये सीरीज में लगे हुए 30 मिली हेनरी, ठीक है। यहां से मैं रिएक्टेंस निकाल सकता हूँ, रिएक्टेंस कितना होगा ओमेगा एल, ओमेगा कितना है 100 मल्टीप्लाई बाय 30 इंटू 10⁻⁻3, तो इट कम्स आउट टू बी 3 ओम। तो अगर आप सोर्स इंपीडेंस देखोगे तो सोर्स इंपीडेंस आ गया R+jXL, आप सोर्स इंपीडेंस कह लो या फिर जो आपका सिंपल इन्होंने बोला है कि सीरीज कॉम्बिनेशन लगा हुआ है, कुछ भी आप बोल सकते हो, उसमें कोई मिस्टेक नहीं है। तो 500 + j3। अब क्वेश्चन के अकॉर्डिंग ये पूछा जा रहा है कि हमारे पास एक अननोन इंपीडेंस है ZL, तो ZL की वैल्यू क्या होगी सच दैट मैक्सिमम पावर मेरी ट्रांसफर की जाए, सच दैट मैक्सिमम पावर मेरी ट्रांसफर की जाए। तो अकॉर्डिंग टू मैक्सिमम पावर ट्रांसफर थ्योरम, according to maximum power transfer theorem, the load impedance must be equal to conjugate of source impedance, right? तो source impedance क्या है मेरे पास 500 + j3 conjugate, तो यहां पर कितना आ गया मेरे पास 500 - j3। तो ऑप्शन सी इज द राइट आंसर, ऑप्शन सी इज द राइट आंसर। सिंपल, अगर आपको कॉन्सेप्ट पता है कि आपका पर्टिकुलर क्वेश्चन क्या, पर्टिकुलर आपका कॉन्सेप्ट क्या है, आप आंसर निकाल सकते हो। सिंपल मैक्सिमम पावर ट्रांसफर थ्योरम का क्वेश्चन है ये, ओके। नाउ लेट्स सी कि कोई और क्वेश्चन बचा है या नहीं। आई गेस नेटवर्क्स का एक क्वेश्चन और था, मैं एक सेकंड में आपकी फाइल ले आऊं, एक सेकंड। नेटवर्क का एक क्वेश्चन और था बेटा, वो अभी हम सॉल्व करते हैं एंड देन वी विल गो टू अ नेक्स्ट क्वेश्चन। So okay, we have one more question of a networks, we have one more question of a network, okay। So question में क्या लिखा हुआ है, we can put a data here। Question is asking what is the value of Q factor, which is quality factor, if the band pass filter is having frequencies। So हमारे पास एक band pass filter दिया, band pass filter we have, so we have a 2 frequencies given, actually corner frequency है, omega 1 is 800 hertz, omega 2 is 1200 hertz, okay। corner frequency given है, So if we have a corner frequencies, then we can find out the bandwidth also, है ना, सिंपल सी बात है. So बच्चों bandwidth का आंसर, bandwidth क्या होता है? Higher corner frequency minus lower corner frequency. Okay, so it will be, अब इसको ओमेगा जगह f कर लो, कोई दिक्कत नहीं है उसके अंदर.
सर
ओमेगा जगह हम यहाँ पे f भी लिख सकते हैं, कोई प्रॉब्लम नहीं है, ठीक है ना. ओमेगा से आप लोग कंफ्यूज हो सकते हो, तो यहाँ पे हम लिख दिया f1 f2, so it will be f2 minus f1, so it will be 1200 minus 800, it comes out to be 400 hertz, है ना. And what is the resonance frequency? Resonance frequency is under root of f1 and f2, so it comes out to be under root of 800 multiplied by 1200. ठीक है. So दो values मेरे पास आ गई है. One is resonance frequency and a bandwidth. Now what they are asking in a question? They are asking a simple thing, quality factor, है ना. So quality factor is equal to resonance frequency divide by bandwidth. Okay, important formula है, याद रखना इसको, काफी एग्जाम्स में आता है. So it will be equal to under root of 800 multiply by 1200 divide by bandwidth, which is 400, and after solving this we will get 2.45 as a answer. Okay, तो सिंपल क्वेश्चन है. सो अकॉर्डिंग टू आवर एनालिसिस अप्रोक्सीमेटली 9 क्वेश्चन आपके आए हैं नेटवर्क से, एंड वो 9 क्वेश्चन यहाँ पे सॉल्व हो चुके हैं. सो नाउ अंकित सर विल कम एंड विल सॉल्व द रिमेनिंग क्वेश्चंस. आइए सर.
Thank you, sir. So students, I hope you would have done well in the exam. So yes, I will be dealing with the questions from engineering maths and signals and system. So students, this question is from Poisson's distribution. If the average number of claims handled daily by an insurance company is 5, so they have given you the average value. So average value means lambda is given, that is Poisson's parameter. Poisson's parameter is given. What proportion of days have less than 3 claims? Assume that the number of claims on different days is independent. So students, ultimately we will just follow the Poisson's distribution. According to Poisson's distribution, P of x is lambda raised to x e raised to minus lambda upon factorial x. And what we want here, just a moment. We want probability for x, yes, the number of claims less than 3, so x less than 3, x less than 3, it means probability for x equal to 0, 1 and 2. So student, we have the value of lambda is 5, so 5 raised to x e raised to minus 5 upon factorial x. Now e raised to minus 5 can be taken out from each of these values, and ultimately 5 raised to x upon factorial x. In this function we can put different values of x. So when you put x equal to 0 in this format, 5 raised to 0 upon factorial 0 will be 1, then we have 5 raised to 1 upon factorial 1, that is 5, and then we have 5 square upon factorial 2, that is 25 by 2. So this will work out as 6 into 2, 12, 12 plus 25, 37. So 37 by 2 e raised to minus 5. So we can say that option A is the correct answer. Yes. So students, moving to the next question. So students, This is a question from signals and system. A continuous time signal is given below. So x of t is given as 8 cos 200 pi t. So student, what we can do here, we can just find out the maximum frequency. So maximum frequency component present in this signal क्या होगा? Yes, can I have your response? So students, the maximum frequency component f max, this will be this 200 pi divided by 2 pi, that will be 100 hertz. And as per the Nyquist rate, that is the sampling theorem, says that Nyquist rate should be, that is the minimum sampling frequency should be 2 times f max, and this is 200 hertz. So 200 hertz, 2 times f max, 2 into 100 will be 200 hertz. So option B is the correct answer. Let's move to the next question. Yes, Payash Kumari. So students, yes, how many number of multiplications is needed in the calculation of FFT with 64 point sequence? So they have given you the length of the sequence, that is n equal to 64. Okay, sir. Now, minimum number of multiplications using FFT algorithm, this will be n by 2 log n base 2. This should be your answer. So what is n? N is 64. 64 upon 2. Then log base 2. N, that is 64. So ultimately, when you solve this, this will come out as 32 multiplied by, yes, 64 can be written as 2 raised to 6. So 6, and log 2 base 2 will be ultimately 1. So 32 into 6 will be 192. 192, option C will be my correct answer. Yes, moving to the next question. Yes, so this question is from bilinear jet transform technique. So this is a technique to convert an analog filter into the corresponding digital filter. So students, in bilinear jet transform technique, we are moving from S plane to Z plane. And yes, the mapping technique will give you the relationship between S and Z. What is that relation? So that relation is S equal to 2 by T 1 minus Z inverse upon 1 plus Z inverse. Okay, sir. So we have got this answer as 2 by T 1 minus Z inverse upon 1 plus Z inverse. Option D is my correct answer. Yes, these are all one-liner questions, very easy questions. Let's move to the next. So students, just a moment. Yeah. The fundamental period of complex signal. So this is again a simple question. X of t is given as e raised to j omega naught t. So students, just a moment. We can say that this e raised to j omega naught t, this can be written as cos omega naught t plus j sin omega naught t. So the fundamental frequency, angular frequency is omega naught. So this omega naught divided by 2 pi, this is your frequency in hertz. What we want? We want fundamental period. So reciprocal of this, 1 upon f naught. So ultimately it is 2 pi upon omega naught. 2 pi upon omega naught. Option A is the correct answer. Let's move to the next. The energy contained in this signal. So student, directly you can say that its formula is 1 upon twice A. So if you are having a signal of this type, x of t, just a moment, if you are having a signal of this type, e raised to minus at into u of t, then energy content in this signal is simply given by 1 upon twice a. And what is this a? If you compare both this, a will be 2. So a will be 2. So 1 upon 2 multiplied by 2, this will be 1 by 4 joules. Let's move to the next question. Yeah. So students, this particular question is based on the property of impulse signal. Which one of the following is a useful property of the unit impulse signal delta t? So students, it's simply just by observation you can say that scaling is done, time scaling is done for impulse signal delta of at. This is equivalent to 1 upon mod of a delta t. Very simple question. Next. Yes, which one of the following is correct for the system represented by the relation y of t equal to x, y of t equal to x. Just a moment. Y of t equal to x sin t. So students, in the options you can see here that we have to check the causality of the system and linearity of the system. So students, let us first check the causality. So if I substitute t equal to a negative value, say minus pi, so y of minus pi, this will be, yes, sine of minus pi will be 0. Now see here, you're observing the input, you're observing the output at minus pi, and you can see here that the input is available at 0. So with respect to minus pi, this 0 is the future sample. So we can say that this system will not be a causal system, this will be a non-causal system because it depends on the future input samples. So this is a non-causal system. Testing the linearity of the system, here argument is sin t. If any operation done on the argument, this will not affect the linearity of the system. So ultimately this is linear. So we can say that this particular system represents non-causal and linear. So which option? Option B is going to be the correct one. Let's move to the next. The Fourier series representations are based on using. So students, we have three Fourier series representations: trigonometric Fourier series, polar Fourier series, and exponential Fourier series. And yes, of course, they are all derived from trigonometric Fourier series, and which is derived by creating an analogy between, yes, the signals and vectors. So when we create an analogy between signals and vector, the concept of Gram-Schmidt orthogonalization process comes into existence, and that orthogonalization process is the foundation for laying the formulae for Fourier series. So orthogonal functions is the base for Fourier series formulae. Fine, moving to the next. Students, a rectangular pulse is given. I will be just writing its mathematical format here. So this rectangular pulse is about 0, having width 2 times t naught. This width is 2 times t naught and amplitude k. So the style of writing this x of t is the coefficient k, then we have rect, then t minus 0 upon the width, that is 2 t naught. Okay, now students, we want to write the Fourier transform. Yes, the Fourier transform of this rectangular pulse. So I will start with rect t. The Fourier transform of rect t, what is that step? it is sinc f, and f can be written as omega upon 2 pi. So this is the Fourier transform vector t. Now what you are doing, you are just doing time scaling by factor of 1 upon t naught. In time domain, what we are doing? We are doing time scaling. Time scaling by what factor? 1 upon twice t naught. Okay. So by doing the time scaling by 1 upon twice t naught, our rectangular pulse now become t upon twice t naught. So what is its impact on the Fourier transform? These bidirectional arrows are showing that there is a change in domain. Okay, so we are now moving to the frequency domain. So 1 upon modulus of a x of omega by a, that is the time scaling property. So 1 upon twice t naught will give me twice t naught. Then sinc, and ultimately this omega upon 1 upon twice t naught will be twice t naught omega upon twice pi. So 2 and 2 gets cancelled here. And if I again amplitude scale by k, I will get k times rect t upon twice t naught, and its Fourier transform will be twice k t naught. Rest of the terms are same. Sinc omega t naught divided by pi. So which option is correct? Twice k t naught. Twice k t naught. Yes. Okay, this 2 is still there. Na? 2 pi is still there. So 2 pi is still there. So omega upon 1 upon twice t naught, this will be twice t naught omega, and 2 pi is still there. Okay, so twice t naught omega and 2 pi is there. We can say that 2 cancelled, omega t naught by pi. So what my option is appearing? Question number 141. I'll just check with the options. For me, option A is the correct one. That's correct. Yeah. So let's move to the next question. Yes, it is omega t naught upon pi. Moving to the next. So students, what is the Fourier transform of the function t e raised to minus mod of t? So students, we have this formula e raised to minus a mod of t. Its Fourier transform is simply twice a upon a square plus omega square. Okay, and I need the value of a as 1. So this will be e raised to minus mod of t. The Fourier transform will be 2 upon omega square plus 1. As I substituted a equal to 1. Now this signal is further multiplied by t. So if you multiply by minus jt in time domain, you need to consider the differentiation in frequency domain. So just differentiate this. What you will get? It is minus 2 upon denominator's square. And again differentiation of omega square will be twice omega. Now I need to shift this minus j to the right hand side. So 1 upon minus j, what it will turn out? It will become, yes, minus 4 omega is already there upon omega square plus 1 whole square. 1 upon j is minus j and this is minus 1, so plus j. So this should be my answer. Minus 4j omega square plus 1 whole square. Minus 4j omega square plus 1 whole square. So option B is the correct answer. So now Ashutosh Saxena sir will be joining with his set of questions. So stay tuned. Thank you.
Thank you so much, sir. How are you guys? I think 43. So how are you guys, and how was your engineering services examination 2023? I hope you must be happy that the examination is little on the easier side, and you must have enjoyed. I think paper 1 was also easy, and paper 2 technical for electrical was also a bit easy if you see in terms of the core subjects, as far as I have seen and I have discussed with other faculties. So everybody who is joining live with me, just quickly share the session with your friends and colleagues so that more and more people are going to be benefited with this effort. So I'll be starting with a couple of questions from power system. So let us see the first question. It was a state question, and he was asking, there was a star connected generator is to be designed to supply a 20 kilovolt line and supply a line current of 10 ampere. So both the voltages and current in terms of the line values is given, and the lagging power factor is also given. He is asking how much reactive power should be supplied by the star connected generator. So it is something like this. It is something like this. You can solve it directly, but just to give you some explanation, suppose this is your 3-phase star connected generator. So the line voltage is mentioned, that is 20 kilovolt. The line current is given as 10 ampere. So basically, simple formula you have to apply. I'm writing here because he's asking for the reactive power. It is going to be √3 line voltage, line current, and this has to be sin phi because it is reactive power. So this is √3. Voltage is given as 20 kilovolts. Current is 10 amperes, and sin phi, because the power factor is given as 0.8, so sin phi is going to be 0.6. So if you calculate it, I think you must be getting B as the correct option. B as the correct option you must be getting, that is 207.84 kVAR. Very simple question. What can be simple than this? Let us go to the next question. Yes, again this was a power, single phase and 3-phase power based questions. A 3-phase balanced star connected motor, now it's a motor, it draws a real power. So real power drawn by the motor is given, that is 5.6 kilowatts. The line voltage is mentioned as 220 volts, and the current, and that too is line current, is 18.2 amperes. He's asking what is the approximate power factor of this motor. So very easily you can find the power factor by the simple power formula as P upon under √3 V into I. So P is given as 5.6 10 to the power 3 under √3, voltage is 220, current is 18.2. If you solve this, you must be getting B, I think, as the correct option, 0.8075. 0.8075. You cannot do calculation mistake in these type of questions, okay? Quite easy. See the next question. Yes, question number 45. Now, this was some interesting question. Even though it was a theoretical question, but it was an interesting question based on the corona phenomena. You all must be aware with the corona phenomena. Corona phenomena happens in case of overhead transmission lines. When the electric field stress is going to be more than a certain value, then there will be some discharge of the current in terms of the, you can say, electron avalanche in between the conductors, and that is a kind of loss. This phenomena we call as corona phenomena. He's asking which one of the following statement is not correct. So you have to choose the incorrect option. The first statement says the corona loss on the middle conductor is more as compared with the two outer conductors. This is correct. Okay, this is correct. B, the corona loss is less in hilly areas than in plain areas. This is wrong. This is wrong. So this should be your answer. Because if you go to the hilly area, what was the logic you have to apply? What was the logic you have to apply? See, corona loss is going to be somewhere, you can say, directly proportional to the air density. Now, if you go to the hilly areas, in the hilly areas, the air density is going to be higher. So corona loss is going to be higher in comparison to plain, because plain areas, air density is going to be less. C option, The rain increases the corona loss in the transmission line. This is correct. The height of the conductors from the ground has its effect on the corona loss. Definitely height is going to have some effect on the corona loss. You cannot say it is neglected. Okay. Even though in general, when we talk about the different factors responsible for the corona, we generally don't talk about the height from the surface of the ground, but it has certain effect. Okay, so you cannot ignore it. But B option is completely wrong, because it is actually more, the corona loss is more in hilly areas than in plain areas. So B is the correct option. Let us go to the next question. Now this question is a very classical question. Actually, this question directly we have seen in our paid classes also, YouTube sessions also, number of marathon sessions we have done this question. So this is about the underground cable. The situation is something like this. This is a single core cable. This is the radius of the core, and this is the outer radius of the sheet. Now he is saying that the dielectric strength of the insulating material is given as 65 kilovolt per centimeter, and the operating voltage is mentioned as 85 kilovolts. 85 kilovolts. 85 kilovolts. Now you know the expression for the electric field stress at the surface of the you can say surface of the core. You can write it as, it is going to be V phase upon R, ln capital R upon small r. But for the condition of overall economic size of the core, you have the condition that the R by R ratio should be equal to E. So if the R by R ratio is E, so what is going to be the value of ln R by R? This is going to be 1. So this simply goes as 1, and it becomes V phase upon small r, and this is given as E, that is, so you can write voltage is 85 and E is 65. So you can find it, I think you must be getting it somewhere around 1.3 centimeters. Now this 1.3 centimeters is not the final answer, because he is asking the overall economic diameter. What is overall economic diameter? Overall economic diameter is going to be this one. This is going to be the overall economic diameter, that is 2R. So it is going to be 2 into 1.3 E. So it becomes 2.6 E. So the correct answer is going to be B. B is the correct answer. How many of you have done this? Just everybody tell me in the comment section. Yes? Everyone? See the next question. Now this was very interesting question. He's asking what is the percentage increase of the bus bar voltage required to compensate for the reactance drop. What is the voltage drop in the reactance of the feeder when the feeder is having a reactance of 5% and is carrying a full load current and 0.8 power factor lagging? So basically, when the current flows through the feeder, what is going to happen? There will be some voltage drop. He is asking for how much value the voltage should be increased. So basically, you have to find the voltage regulation. In general, what is the expression for the voltage regulation? This is R per unit cos phi plus X per unit sin phi. Now here R per unit is not given. So you can assume it to be a lossless feeder, so that R is going to be 0. If R is 0, what is the X per unit? It is given as 5%. So this is 5%. What is the value of sin phi? Now see, power factor is given as 0.8. It means cos phi is given as 0.8. So what is going to be sin phi? This is going to be 0.6. So if you solve this, you will be getting 3% as the answer. So what is the correct answer? A. 3% is going to be the correct answer. Everybody, yes or no? Are you able to follow this? Now this was the question based on the operating time and the plug setting multiplier characteristics for different relays. So if you observe, he is asking curve B is going to represent which of the relays. Now please understand the nature of curve B. If you see the nature of curve B, this is the curve. This is the curve. So you will observe when it is very close, because the time is very less, then the time is going to be very high. When the plug setting multiplier is very near, the time is you can say very high, but as it is increasing, it is slowly becoming constant. It means this is going to be inverse definite minimum time. minimum time relay, the most popular one, IDMT relay. Okay, so near the pickup value, this is the pickup value, near the pickup value, it is going to be inversely proportional, and beyond that, it is going to be constant. So this is the answer. I think you must have done it correctly. D is the correct answer. Yeah, this was an interesting question. It was not just a power system question, it was a reasoning question also. So this table you have to make with me. This is a load bus. This is a slack bus. Okay. And this was a generator bus. And he is saying these are the quantities which are specified. So specified I am writing as yes. And quantities you have to find. These are unknowns. This I am writing as cross. Now set A is mentioned here, set A. So what are the quantities known for load bus? This is real and reactive power. What are the quantities unknown? Voltage magnitude and voltage phase angle. For slack bus, what are the quantities known? Voltage magnitude and phase angle. What are the quantities unknown? P and Q. For generator bus, what are the quantities known? P and magnitude V. And what are the unknowns? It is reactive power and voltage phase angle. So this is set A. This is set D. This is set B. This is set E. And this is set C. And this is set F. Now you see the options. Option 1 says set A and E are same. So set A is PQ, set E is also PQ. It means A and E are same. So this is correct. B and F are same. What is B? V and del. What is F? Q and del. So this is not same. It means option B cannot be the correct answer. Okay. C and D are same. What is C? P and V. What is D? V and del. This is also not same. C is also incorrect. D says C and E are same. C and E are same. C and E are same. No, they are not same. So this is incorrect. So only A option is going to be correct. A and E are same, and set C and D are different. C and D, they are different. So perfectly, what is the answer? Yes, Dayal, it is going to be A. Very interesting question. I hope you must have done it correctly. Yeah, see this next question. He's asking about when you are following the load flow solution by using the Gauss-Seidel iterative method. Gauss-Seidel iterative method, including the PV buses. When the PV buses are also included, what is going to be the reason for the violation of reactive power limit? You must be knowing this, that if the reactive power limit is breached, then what you do? Suppose for any bus you are getting Qi less than Q minimum. So what you will do? For that iteration, you will fix the reactive power for injected reactive power for that bus to the minimum limit. And for that iteration, you will treat this PV bus as PQ bus because you have fixed the Q value. And similarly, if it is more than the maximum limit, then what you will do? Again, you will fix it to the maximum limit. And for that particular iteration, you will treat it as a PQ bus. But in the next iteration again, you have to treat it as a PV bus only. Now, what is the reason for this? The reason for this is that the voltage what you have chosen, voltage level, it may be either too low or too high. So if the voltage is too low side, then the minimum limit is going to be breached. If the voltage is too high, what you have chosen as the starting guess, then it is going to be breaching the maximum limit. So what is the correct option? C. What is the correct option? C. Let us see the next one. Yeah. Now this question, you don't even need to pick up the pen. Directly you just put the answer, you fill the bubble. Now the equal area criterion is given here, and he is saying that the mechanical power input is increased suddenly from P0 to PS, and 3 operating points are mentioned, A, B and C, and he is asking exactly at point B, what is going to be the relation between the electromagnetic power. Electromagnetic power is the power generated by the generator, and PS, that is the demand or input mechanical power. In both ways you can understand. Now if you understand what is the phenomena, please understand. At a point del is equal to del naught, everything was happy, everything was good in the generator's life. But suddenly when you increase the motor output, what will happen? The demand is more and what is power generated is less. So definitely the generator has to accelerate. Why? Because how the generator works. Flux is there, field is there. If you rotate the generator with a higher speed, more amount of flux is cut and more EMF will be generated, more power will be generated. So the rotor is going to accelerate from this point A to point B. The moment it reaches point B, it will not stop because the rotor of the machine is going to have some mechanical inertia. That inertia will keep it moving up to point C. The moment it reaches point C, again it will come back and it will try to achieve the stable point B. But again, because of the inertia, it will go beyond this point. And this swinging will happen until and unless finally point B is achieved. But at this point B, there will be an equilibrium in between the electromagnetic power and the power demand. P electromagnetic is equal to PS. So A is going to be the correct answer. A is going to be the correct answer. Everybody, yes or no? Let us see the next question. Now this question was little similar. He is saying that there was a generator. There was a generator. So you represent the generator action something like this. This is the generator. This is the shaft of the generator. You are giving some mechanical input by using the prime mover. So some mechanical torque you are providing by this. If the rotor is free to rotate, it will start rotating in the same direction. But because it is a machine, because there are two windings, two fluxes interacting together, so definitely there will be electromagnetic torque in the opposite direction, and the interaction between this electromagnetic torque and the load torque will give rise to the output electrical power. This is the case. Now he is asking what is the net torque causing the acceleration TA. So please understand, TA is going to be prime mover torque. This is the prime mover torque minus this is the electromagnetic torque. Because here the source is here. In case of generator, where is the source? This is the source. Prime mover is the source. So this is going to be TS represents the shaft torque. So this is going to be TS. So you can write TS minus, and this is going to be TE. So TS minus TE, A is the correct option. A is the correct option. I hope it is clear, everybody. Let us see the next one. Now this question was related to the generating stations. Okay, sometimes it is these type of questions they are asking, so don't need to worry about it. Generally, many students are not sure about these concepts, so you should avoid these type of questions. If you know confidently, then only you answer. Don't try to make a guess, otherwise there will be negative marking. So basically, when it is totally embedded in the fluid and powered from the pressure drop across the device, it is the impulse turbine. It is the impulse turbine only. So generally, we don't read up to this much depth. It is a fact. So you don't need to go after these questions. You can leave them very safely. No problem. Okay. So this was what I wanted to discuss for power system. Now, the most respected, my favorite and your favorite and everybody's favorite, the legendary faculty for computer science, Satya sir is coming. Over to you, sir.
Thank you, sir. Thank you. Thanks for the warm welcome. Hello, guys. Now, let us discuss computer fundamentals questions. Myself, Satya. Okay, guys. Everyone, how did you write your ESE paper 2? Here is the first question we have got from computer fundamentals. Guys, keep liking the session, keep sharing the session. Come on. So here is the question we have. A benchmark program is run on a 200 megahertz processor. So, see, from this, what we can understand, first thing is the processor clock frequency is 200 megahertz. When the frequency is 200 megahertz, what would be the clock cycle time? The cycle time of the processor would be 1 by 200 megahertz, we can say, isn't it? This is equal to 5 nanoseconds. So this is the first thing we have to do. Then go on. The executed program consists of 1 million instruction executions. 1 million instruction executions. Okay, means these instructions are executing 1 million number of times. Okay, with the following instruction mix, we have different set of instructions like arithmetic and logical, load and store, branch, and some other sort of instructions. Okay. And clock cycle count. Now you please observe how many arithmetic and logical instructions we have. 8 million. 8 million. Okay. 8 million instructions. For every instruction, how many cycles we require? 1. So total cycles, if you count, total cycles would be, we have 8 million and every cycle require, every instruction require 1 cycle, plus 4 million instructions, every instruction require 3 cycles. Go on. And similarly, 2 million instructions, every instruction has 4 cycles, plus, and we have 4 other instructions, 4 million other instructions, every instruction require 3 cycles. So what is all this together? 8 plus 4 or 12 plus 8 plus 12. So 12 plus 12, 24 plus 16. This is 40 million cycles. What is this? 40 million cycles is what? Total cycles. Right? Now, please understand, for 1 cycle, 5 nanoseconds time. And for 40 cycles, how much time? For 40 cycles, we say 40 into 5, 200 nanoseconds time. Right? Now, what we want? We want mega instructions per second or millions of instructions per second, dear friends. So, what we do? See, for 1 instruction, or yeah, let us put it in this way. Let us put it in this way. See, for 1 nanosecond, for 1 nanosecond, you see, 1 instruction require 5 nanoseconds time in this way, right? Okay, fine. No worries, no worries. So here we have got total cycles as we have calculated as 40 cycles, and 1 cycle time is equal to 5 nanoseconds. First point is that. Now we want to find out millions of instructions per second or mega instructions. How many mega instructions per second? This is what we want. With respect to. So here you please understand, 200 nanoseconds is the total cycle time, because we have total 40 cycles, 40 million cycles, sorry. Okay, 40 million cycles. Now for 1 cycle, this is what that 1 cycle time is what? 1 cycle time is what? 5 nanoseconds. So total cycle time, if you calculate, that is going to be 40 million into 5 nanoseconds. Let it be. Now we want to find out this with respect to 1 million. Hence, what it is going to be, dear friends? Here you see one point which is very important is, we have such 1 million instruction executions. 1 million instruction executions, right? So total, how many million instructions we have? Total instructions, if you count, this is 8 plus 4 plus 2 plus 4, that is 8 plus 4, 12 plus 2, 14 plus 4, 18 million instruction executions. Right? So all together, how many we are getting? 90 million instructions. Because you see, here for 1 cycle, we require 5 nanoseconds time. right? Now you please understand, we have 18 million instructions, millions of instructions per second. One cycle time is 5 nanoseconds, and it occur 1 million instruction executions occur, means it occur 1 million times. So 1 million is what? 10 raised to 6 or 1 mega. So here we got mega instructions per second. So it is 18 into 5. That is how we get 90 mega instructions per second. So the answer for this would be option A. Option A would be the right answer, guys. Now, yeah, let us see the next question from computer fundamentals. What is the exponent length in bits for IEEE double precision floating point format? So what is the standard allocation of bits for double precision, guys? We have sign, exponent and mantissa, and the total length for double precision floating point number is 64 bits, right? Now for sign we know it is always 1 bit, and for exponent 11 bit, and the remaining 52 bits would be for the mantissa. So 11 bit would be the answer for this. 11 bit would be the answer for this question for IEEE double precision floating point format. Okay. So guys, how many of you given the correct answer for this question? Please give your response in the chat box. How many of you have given the correct answer for this question? Chalo, next question. Yeah, this is the direct question, guys. Which of the following instruction formats is designed to be a large scale time shared system with an emphasis on making the system easy to program even if additional hardware expense was involved? See, we have got this PDP systems in different versions. This time sharing concept is introduced in which version, guys? PDP 8. PDP 8. This is the direct question, and it don't require any more explanation. Now, let us see the next question. Yeah, see this question. This is based on machine parallelism, parallel processing. See, which of the following statements is correct for machine parallelism? We have 4 statements. It is a measure of the ability of the processor to take disadvantage of instruction level parallelism. It is the measure, okay, of ability of the processor to take drawback of instruction level parallelism. Definitely no. And it is determined by the frequency of true data dependencies and procedural data dependencies in the code. What is what? Machine parallelism, is it determined by frequency of true data dependency? Means you can say true data dependency, output data dependency, RAW, raw hazard, or write after write, WAW hazard. We have data hazards, no? Read after write, write after read, write after write. So it is telling the machine parallelism is determined by the frequency of true data dependencies and procedural data dependencies in the code. Not only these, by other parameters also. So let us not take this. Okay. It is determined by the number of instructions that can be fetched and executed at the same time, and by the speed and sophistication of the mechanisms that the processor uses to find independent instructions. Exactly. See, the right answer would be this, because when we want to execute the multiple instructions in parallel more favorably. If they are independent instructions, we can run them simultaneously, right? So we have to find how many instructions that are independent so that they can be fetched simultaneously in parallel. So the degree of parallelism we can say by the number of instructions that can be fetched and executed at the same time. It is determined by the time until the result of instruction is available. No, it is talking about some halts or stall cycles. So no. So the right answer for this question is option C. Option C. Yes, guys, how many of you have given the right answer for this question? Option C. How many of you have marked it? Option C. Everybody, give your response. Give your response. Next. Okay. Here we have, consider a main memory consisting of 4 kilo blocks, a cache memory consisting of 64 blocks, and a block size of 32 words. Compute the number of bits in the main memory address using direct mapped cache technique. Actually, guys, if you carefully observe this, it's a trap. There is no need of this cache memory size. There is no need of cache memory size because we are, however, finding the number of bits for main memory address. In the main memory, the data is organized in the form of words. Now, total number of words in main memory. How many number of words in main memory, guys? Main memory is having 4 kilo blocks and each block size is 32 words. So total number of words in main memory are 4k multiplied by 32. This is 2 raised to 2 multiplied by 2 raised to 10 multiplied by 2 raised to 5 I can write. So altogether it is going to be 2 raised to 17 words. So when we are having total 2 raised to 17 words, every word will have how many bit address? 17 bit address. So main memory address length would be 17 bits. So the right answer for this question should be option B. Come on, guys, keep responding. Make the session interactive. Make the session interactive. Everybody, give your response. Have you marked the same answer for this or not? 17 bits is the right answer for this question. Okay. Now let us move on to next question. Next question. Okay. Again, a direct question. The answer, half answer is in the question itself. Please look at the question and read the question carefully. Which one of the following methods is used when the processor issues an IO command, continues to execute other instructions, okay, and is interrupted by the IO module when the latter has completed its work? Yes, थोड़ा समझने के लिए टाइम लगता एक क्वेश्चन, क्योंकि ये थोड़ा ट्विस्टिंग में दिए थे इधर उधर करके. इसका मतलब मैं समझाता हूं. See, it is giving that CPU is executing some work. Okay. Now, an interrupt occurred. From where? From an IO module. Now, CPU won't attend that interrupt immediately. Won't attend that interrupt immediately. After finishing the current instruction execution, then CPU got interrupted. After finishing the latter, CPU got interrupted. So it happens when? In the interrupt driven IO mode. In the interrupt driven IO mode. Okay? Come on. Next question, guys. Yes. Which of the following statements is correct for atomic data? This is the question from database. Now, It's a direct question, guys. If you look at the options, atomic data means it is the data that consists of single piece of information. Atomic itself says that, which is undivisible. So which is having single piece of information, that is, they can't be divided. So undoubtedly option D is the right answer for this, right? Let's proceed to next question. Okay, here we have a question. Consider 4 processes P1, P2, P3, P4 with burst and all arrive at time 0. So we are given the burst and arrival time. What is the average waiting time for SJF, shortest job first algorithm? Come on guys, this is very easy. When all arrived at time 0, what is the Gantt chart we draw? At a time 0, all are available. So which is the shorter? P4 is the shorter. Okay. It run from 0 to 3. Then which is the shorter? P1 is the shorter. That run from 3 to 9. Then P3 is the shorter. 9 to 16. And then P2, 16 to 24. So this is the Gantt chart. Now what is the waiting time of P1? P1 arrived at 0, started at 3. So for 3 units of time it is waiting. P2 arrived at 0, started at 16. So 16 is the waiting time. P3 arrived at 0, started at 9. And for P4 arrived at 0, started at 0. So no waiting time. So what is the average? Average equals to 16 plus 3, 19 plus 9, 28 divided by 4, which is 7 milliseconds. So 7 milliseconds is the right answer for this question, dear friends. Chalo. Next question. Yeah. The processes that are residing in main memory are ready and waiting to execute are kept in a list called ready queue, means in the ready state. That queue generally stored as priority queue. Priority queue, because if the high priority processes come, they will be immediately scheduled to running state. Hence, generally the ready queue will be maintained in the form of priority queue, no doubt. Okay, next. When a process creates a new process using the fork operation, which of the following states is shared between parent and child process? The name itself says shared memory segments are only shared by the parent and child processes. The other stack, heap, of course linked list is not at all relevant to this. Stack and heap are separated or dedicatedly allocated for both parent process and child process. Okay, so the answer is, which is shared by parent and child, shared memory segments. Chalo, next question. Okay, I think this is the last question of computer fundamentals, dear friends. Consider the following statements regarding thread pool. Thread pool, which is used in multi-threading environment like Java programming language, right? Why it is used, I'll just give you in 10 seconds. Thread pool means every time creating a new thread, full the memory. So memory overflow occurs. That's why thread pool is the concept which reuses the existing threads, simply. So we can say a thread pool limits the number of threads that exist at any one point, and that is particularly important on systems that can't support large number of threads. Yes, this is what the reason why we require this thread pool. So definitely option 2 must be true. Okay, let us filter out the options. Okay, this is one best way we can do. So option 2 must be right answer. Okay, now it allocates memory and initializes a new thread. Definitely thread pool initializes a new thread. This is wrong, guys. Thread pool use existing thread. It is telling it create a new thread, allocate memory and initialize a new thread. That is wrong. Thread pool concept is to utilize to reuse the existing thread. So when option 2 should be definitely true, option 4 is definitely false. What you can say? Definitely the right answer is option A. 1 and 2 only, 1 and 2 only. These two options are the correct one. Okay, I think yes, these are the 12 questions we have got from computer fundamentals. Guys, keep liking the session, keep sharing the session. After this, one more. I think one more question, guys. Sorry. Which of the following is used for recognizing the magnetic encoding numbers printed at the bottom of a check? At the bottom of the check, whatever the characters that are printed, to verify them, what is the technique used? Magnetic ink character recognition. That is called as what? Magnetic ink character recognition. Okay, I think yes, we are done with the computer fundamentals now. Now our favorite Saket sir will join us to discuss some more questions. I welcome Mr. Saket sir, please sir. Thank you guys. Thank you sir.
Good evening, everyone. So I hope that communication question also you have done, because we have already solved so many questions in the vision batch, and I hope that you have done the question very easily. Okay, so this is the question from your band pass transmission. So we have only 4 chapters, you know, and all the 4 chapters we have done in our vision batch, and very simple and straightforward question came from the topic. This type of question also we have solved. So what is the spectral efficiency of 16 QAM? So spectral efficiency is given by bit rate divided by bandwidth, right? Okay, so this is the spectral efficiency, bit rate divided by bandwidth. So what was your answer? You now tell. If I calculate the bandwidth for the 16 QAM, okay, so bandwidth for M array QM, let us suppose, then it is nothing but a 2 into RB bit rate divided by log base 2M, right? And we want to calculate the bit rate divided by bandwidth. So the rho is bit rate, which is RB, and this is 2RB divided by log base 2M. Okay, so this RB and RB will get cancelled, and we will get log base 2M divided by 2, right? And the number of symbol is 16 over here. So log base 2 16 is your 4, and 4 divided by 2 is 2 bits per hertz. So the correct answer will be option B, right? So the correct answer will be option B, because the nothing is mentioned. So we generally calculate the spectral efficiency only for your rectangular pulse. So if you calculate it for, suppose, for the raised cosine pulse, then you have to replace RB by 2 1 plus alpha, and you will calculate the minimum bandwidth. Then you will get the answer as 4. As you can see in this particular question, somebody has marked the option D, but because in such type of calculation, especially in the spectral efficiency, we take the rectangular pulse, and according to the rectangular pulse, the answer will be 2 bits second per hertz. Okay, so now coming to the next question. Okay, so now coming to the next question. A continuous time signal is given below. X of t is equal to 8 cos 200 pi t. So what is the minimum sampling rate required to avoid aliasing? So we know that to avoid aliasing, we need minimum sampling frequency as the Nyquist rate, which is twice of maximum frequency component of message signal. So this is 2 into what is the maximum frequency of the message signal? It is 100. So the answer is 200 hertz. So very direct question, straightforward question. Option B will be the right answer. Next question. Yeah, so the signal power and the noise power measured at the input of and amplifier are 150 and 1.5 microwatt respectively. If the signal power and the noise power at the output we are calculating is 1.5 and the 40 milliwatt, then what is the amplification noise factor? So what do you mean by amplification noise factor? The amplification noise factor is nothing but a noise figure. So the noise factor or the noise figure is given by input signal to noise ratio divided by output signal to noise ratio. Okay, so what is the input signal to noise ratio? So it is nothing but a 150, both are in microwatt, so this is 150 and 1.5, and the output signal power will be more, that is 1.5, and the noise power which is 40 milliwatt. So when you will solve it, you will get the answer as 2.666. So the answer will be option A. Okay, so this is your option number A. Next question. So this is the question from information theory. So generally they ask the question from the information theory as well. So there are probabilities given for the 5 symbols in fact. And what is the entropy? So the entropy is given as summation over I is equal to 1 to m, the probability of the symbol, and log base to 1 upon probability of that particular symbol. So the probabilities are 1 by 2, 1 by 4, 1 by 8, 1 by 16 and 1 by 16. So when you will calculate, this is 1 by 2 log base to 2 plus 1 by 4 log base to 4 plus 1 by 8 log base to 8, because inverse of probability is there, and 2 times 1 upon 16 log base to 16. Okay, so when you will solve it, you will get 1.875 bits per symbol. So the answer will be option B. Next. Yeah, so this is the direct question from the amplitude modulation. What is the modulation index if the maximum envelope and the minimum envelope of the AM signal is given? So the modulation index is given by MA is equal to E max minus E min. Direct formula based question came from the communication. So E max plus E min. So when you will substitute these values, this is 150 and 70. So 150 minus 70 divided by 150 plus 70, and you will get 0.364, or you can say 36.4%. That is option C. Yes. Coming to the next question now. Yeah, so this is the question from the noise. So again, this question also we have solved in our vision batch. That is the last topic we discussed in the particular batch, that is the noise, where we discussed about when the cascade systems are connected, what will be the overall noise temperature and what will be the overall noise figure. So all these things we have already done. So the noise, this is 4 kTB into R, mean square value of noise voltage. So just we need to substitute all the formulas. That is 4 into 1.38 into 10 raised to power minus 23, and the temperature we have to convert in the Kelvin. So there are 25 degrees Celsius is given, so it is 298, and the bandwidth is given as 4 megahertz. So put this value 4 into 10 raised to power 6, and the resistance is given as 10 kilo ohm. So 10 into 10 raised to power 3. So when we substitute all the values and solve, we will get 25.65. So option C, 25.65 microvolt. So that is the answer we are getting. Okay. Now Ashu sir is joining for your other subjects of electrical.
Machines and power electronics.
Machine and power electronics. Yes.
Thank you, Saket sir. So guys, I hope you all are enjoying. So now we'll discuss with the machines and power electronics. Okay. So these were the questions, and in the previous session, because I have joined one more previously. At that time, I told you that there were some remaining questions from power electronics. So I have combined power electronics and machine now. So let's try to solve these questions. So the question number 85 is, isolating transformer are commonly used in many type of electric circuit for the purpose of. Now isolating transformer are 1:1 transformer. Okay, turn ratio is generally 1. So in isolating transformer, DC cannot, actually in transformer you cannot supply DC. I mean DC cannot be passed to the secondary side, okay, because of the DC component of the current, the flux become constant and the rate of change of flux becomes 0. That's why to block the DC, isolation transformer are used. So the answer is blocking direct current signal while maintaining the alternating current continuity between the circuits. So answer is Calcutta. Okay, so answer is Calcutta. For this question, answer is Calcutta. Okay, let's move to the next question, guys. So let's move to the next question, and the next question is, when there is no ferromagnetic material but only air present between the coil, such a transformer is called. Now generally we call this type of transformer as air core transformer, but there are no option like air core transformer. One is iron core transformer. So obviously iron core, if there is a core, then there is no point of writing air in the core. Okay, so this is wrong. Steel core, this is wrong. Wet type, this is again wrong, because wet type is generally we use outside our houses. Okay, distribution transformers or maybe power transformer, they are generally used wet type. Now dry type, that might be correct, because all the options are not correct. So even in dry type transformer we use magnetic core, but the only suitable answer is dry type. Okay, that's why the answer should be Delhi. Okay, so the answer should be Delhi from my side. Okay, now let's come to the next question, and the next question is, the objectionable audible humming sound in the core of the transformer is due to magnetostriction, and it can be minimized obviously by decreasing the flux density. Okay, by decreasing the flux density. Okay, so the magnetostriction happens when the dipole moment rotates, and higher the magnetic flux density, then the strength of rotation will be higher. So that should be the correct answer. Let's move to the next question, guys. So the next question will be yes, this is a good question, and in this question the ideal two-winding transformer primary side number of turns is given as 100 and the secondary turns is given as 200. The mutual coupling flux, the mutual flux is given as the flux phi m. The flux phi m is given as, so phi m is equal to, it is provided as minus 0.05 t square minus 2t. Okay, this is my mutual flux, and the terminal voltage we need to calculate. So the terminal voltage E will be equal to, induced EMF ET will be equal to minus n d phi by dt. Why I am taking minus? Because of Lenz law, and the polarity is not given. Okay, since the polarity is not given, that's why I have to take minus n d phi by dt. So the minus, or since you are asking the primary side, so I have to take n1 turns. Okay, so minus of n1 is 100 into d phi by dt. If you take the derivative, it will be minus 0.05 into the derivative of this is 2t minus 2. Okay, now you take 2 common, so it will become 0.1. Okay, and minus will become plus, so it will become 10 into t minus 1. Okay, this should be the correct answer. So answer is Agra. Okay, answer is Agra. Let's move to the next question, guys. So the next question is, wait a minute, let's move to the next question. So the next question is on your screen. We have a 345 kV transmission line feeds a distribution system that in turn has radial feeds to 4160/2400 volt 4-wire distribution system. So we have a transmission line, and that transmission line goes to the substation, and from the substation we are supplying some 4-wire distribution system. Okay, and in a distribution system we used delta star transformer. Okay, and the primary side of the delta is 4160. Okay, 4160. That in turn has radial feed to 4160 to I think this is my transformer rating, because it's not clear in the question. Let me tell you guys, I don't know whether this is the transformer rating or not. So I suppose that this is the transformer rating, 4160 volt to 2400 volt, and for that we use delta star transformer. Okay, and the transformer is of 100 MVA, now we need to calculate the line current on delta side. We know that this 100 MVA has to be equal to 100 MVA. MVA means 10 is to the power 6. That has to be equal to root 3 VLIL. Okay, root 3 VLIL. So obviously from here you can calculate the IL if we know the value of VL. Now VL, where is VL? VL is not known to us. If you are taking this as VL, then it is problematic. Why? Because I don't know whether this is a transformer rating or not. I'm not sure. So what we are going to do is, first we are going to take this, because it might be possible that this radial feed, I mean whatever this rating is given, it's not for transformer. It might be possible. It might be possible that he wants to say that the distribution radial system has either this voltage or this voltage. It might be the possibility. Okay, this voltage or this voltage. So you can take either this voltage as the output or this voltage as the output. So I don't know in which term he's saying that, but let's try to solve this using this formula. So if I use this formula, now using this formula, I can calculate that IL is equal to, let me erase that part. IL is equal to, wait a minute. Yes. So using this, we know that 100 MVA is equal to root 3 VLIL. So now from here you can see that IL will be equal to 10 is to the power 8 divided by root 3 into VL. Now what is the line voltage? If this is the rating of the transformer, then this side is delta side and this side is star side. So if I put this VL, this VL, because I am assuming that this is the transformer rating. So if this is the transformer rating, if this is the line voltage, then if I put it here, then the IL came out to be 13879 ampere. Approximately this much of ampere will come out. If you taking this voltage as the delta side and this voltage as the star side, but this option is not given in any option. Okay, this answer is not given in any option. That's why I'm not taking this answer. Now, I am assuming that the line voltage is this. I mean, the delta side voltage is this. And the star side voltage is either this voltage or this voltage, because the distribution system is there. In distribution system, either I'm supplying this voltage or this voltage. It means this is the secondary side voltage I'm taking. I'm not taking this as transformer rating. I hope it is clear. So if I take this as delta side, then I have to divide with 345 kV. Okay. If you divide with 345 kV, then the IL value will came out to be 167.35 ampere, which is provided in the option. That's why I go with the A. Okay, because there is no point with going with the D answer. Okay, because the decimal is not correct. I hope it is clear. So I am assuming that this side is the distribution side, and on this side, this is the secondary side voltage, either this or this. I'm not taking this as transformer rating. I hope it is clear. Okay, so I mean the question is not pretty not clear. That's why I'm giving you this answer. Let's come to the next. Let's come to the next question. So the next question is, we have a 4-pole lap wound. Now number of pole is 4, lap wound, it means the number of parallel path will be equal to 4 again. DC armature has 54 slots, so we have 54 slots. Okay, 54 slots with single turn coil. Okay, single turn, 1 turn coil. We have 1 turn coil. How many armature conductor are required if there are 2 coil sides per slot? Okay, per slot there are 2 coil sides. Okay, so if there are 54 slot, obviously there has to be, if there is no two coil side per slot, let's take single coil side per slot. If I take single coil side per slot, then the number of coil has to be 27, because 1 coil needs 2 slot. Okay, so you can say that 54 slots means 27 coils. Okay, so if you take 27 coils, then per slot there is 1 side, but actually it is given that 2 coil side per slot. In 1 slot there are 2 coils, so the total coil has to be 54. Okay, total coil has to be 54. It means 54 turns. Total turns are 54. If total turns are 54, then total conductor will be double of that. So answer is 108. Okay, answer is 108. I hope it is clear. Answer is Delhi. Okay, let's move to the next question, guys. Let's move to the next question. And the next question is, let's move to the next question. So the next question is this: the magnetic core of large transformer are built in stepped cores. I mean, the core is made up of in step type. Stepped core is used in large transformer, and why it is used? To minimize the use of copper and decrease the copper loss. So answer is Calcutta. Okay, so it's a direct question. Okay, and it depends on your memory. So obviously the answer is Calcutta. Okay, let's move to the next question, guys. Let's move to the next question, and the next question is next question you can see on your screen. So the next question is an auto transformer has advantage over the two winding transformer. Which advantage the auto transformer has? No electrical isolation. No, this is not an advantage. Greater short circuit current. Again, this is not an advantage. This is disadvantage. Higher excitation current. This is again not an advantage. Lower leakage reactance. Yes, that's correct. Lower leakage reactance. So answer is Delhi. Okay. Let's move to the next question, guys. So these questions are very easy. Let's move to the next question. So the next question is, wait a minute. Yes, next question. So in the next question, you can see that the stator and rotor slot of, yes, this is a very good question. And I think according to my understanding, because it might be possible that I have not understood the question correctly, but according to my understanding, the stator and the rotor slot of an induction motor are designed to traverse the axial length of the magnetic core at an angle from the true axial direction. It means, let's say you have a rotor. You have a rotor like this, and the slots are like this. Okay, the true axial direction is this. This is true axial direction. Okay, and the slots are at some angle theta. Okay, now the average value of MMF over the axial length of the magnetic core is. He's discussing about the instantaneous average. He's discussing about the instantaneous average, like in PWM, if you remember, the instantaneous average. So I think the instantaneous average will be like this. I mean, it will be like a ramp or like triangular. But I'm not sure. Why I'm not saying ramped transition. It should be ramp transition, but I'm going with triangular transition. Why? Because I'm not sure how many stator slots are covered from this point to this point. It might be possible that number of slots are higher. That's why it might be possible that the wave become triangular. Okay, so the answer should be triangular transition according to my understanding, but I'm not sure about this question. So let me tell you guys, I have to check this question and then I'll come back. According to my understanding, up to this point, I think this would be the correct answer. Okay, let's move to the next question. And the next question is, okay, next question is, again, it's very simple question. Now in this question we have a 4-pole 50 Hz 3-phase induction motor. We have number of pole as 4, frequency as 50 Hz. Okay, and 3-phase induction motor. Shaft speed is 1750 rpm. What is the speed of stator air gap MMF wave? Stator air gap MMF wave. Okay, now the stator air gap MMF wave is the synchronous speed, so it's 120 F by P. Okay, so it came out to be 1500 rpm. Now if you convert this 1500 rpm in radian per second, multiply by 2 pi by 60, you'll get the answer as 157.07 radian per second. Okay, I hope it is clear. The speed of the stator air gap MMF. Now this question is not correct, by the way. Why? Because the speed of stator air gap MMF wave with respect to what? If it is saying with respect to stator, then this answer is correct. But if the question is with respect to rotor, then the answer will change. But I'm assuming that he's asking with respect to stator only. Okay, that's why this answer is correct. Okay, let's move to the next. So the answer will be relative. I mean, the information is not given. So let's come to the next question, guys. So in this question, again, prior to replacing a 3-phase Y-connected synchronous generator in service on a Y-connected electric utility grid, 3 lamps are connected across the open contactor, served as indicator to assure synchronization condition if the lamp will blink off and on, which indicates. It means the bulb is blinking on and off. So which option is correct? Obviously, if the bulb is blinking, what does it mean? It means voltage is same, but the frequency of incoming machine is not the same. Okay, so answer should be Bombay. The frequency of oncoming synchronous generator and the electric utility are not equal. So answer is Bombay. This was very easy question. Let's move to the next question, guys. And the next question is on your screen. So this question is again very good question, and I have solved this question. So yes, I have solved this question. And a primitive stepper motor and its digital driver circuit is furnished with a train of f pulses per second, that the input of the controller is divided so that the output is sent in the sequence to one pulse winding at a time, with 2p as the number of phases. Okay, 2p as the number of phases. Okay, and k number of teeth. K is number of teeth. K is number of teeth. Okay, now the question is, then the rotor angular motion per pulse in a step. Okay, the rotor angular speed is asking. So the angular speed of the rotor, the formula you can directly apply. That is 360 divided by MP. Okay, divided by MP. 360 divided by MP. Now 360 is divided by M. M is, what is M? M is number of phases, or P is number of teeth. So you can write it like this: 2P into K. Okay, so it came out to be 180 upon PK. 180 is pi. Pi upon PK radian per second. Okay, pi upon PK. So answer is Delhi. Let's move to the next question, guys. Let's move to the next question, and the next question on your screen is this question. In this question, if the step down chopper operates continuous conduction mode with duty cycle D, the ripple factor. Okay, so we have a step down chopper. In step down chopper, we know that the output voltage will look like this. Okay, output voltage will look like this. Let's call it VD, and this voltage is V0. We know that you can make the step down chopper like this. This is my supply voltage VD. We have a switch, and here we have the load. Okay, here we have the load. Now you can see that whenever this switch is on, this switch will be off. Whenever it is on, the output voltage will be VD, and whenever it is off, this switch has to be on and the output voltage will be 0. Okay, so this will be my output voltage wave shape. Now I need to calculate the ripple factor. We know that the average value V0T average will be equal to dVd. Okay, V0T average is dVd. Now what is V0T RMS? V0T RMS is equal to a root of the time period. Time period is t, this time is dt. So 1 by t integration 0 to dt, and the value is Vd square dt. Is it clear, guys? So this is my RMS value. So if you calculate this RMS value, it will become Vd square into d, and take the root of that. This is my V0T RMS. V0T RMS value. Okay, and V0T average is this. Now the ripple factor will be equal to root of V0T RMS square minus V0T average square divide by V0T average square. Okay, so this is the formula. So if I apply this formula, V0T RMS square, so it will become Vd square into d minus V0T average, so it will become d square Vd square divide by d square Vd square, and you have to take the root. So that Vd square will cancel, it will common out, and the d square, the root of d square is d. So in the numerator you have root of d minus d square, in the denominator you have d. So answer is Agra. Answer is Agra. I hope it is clear. Okay, so answer is Agra. D minus d square root divided by d. Okay, let's come to the next question, guys. Let's come to the next question. So the next question will be, yes, it is on your screen. Next question: a wound rotor or slip ring synchronous motor is commonly used as drive in overhead cranes and load equalization. Now it is not visible to you, I suppose. So this is 116, question number 116. So in overhead cranes and load equalization, we generally use stator voltage control. Remember this, stator voltage control. If you remember this, then only this option is correct. Otherwise, I mean, you will not be able to solve this question because it's a memory based question. Okay, so a wound rotor slip ring induction motor is commonly used as drive in overhead cranes and load equalization. So whenever induction motor is used in this purpose, then there should be voltage, stator voltage control that we generally use. Okay, let's come to the next question, guys. In the next question we have, which of the following statement is correct in series resonant converter? So in series resonant converter, let me check. I have solved this question, and this question number, this is power electronics now. Okay, so in series resonant converter, the output voltage waveform depend on the damp. Yes, in series resonant converter, generally we have a, like, let me draw the circuit. We have an inverter, okay. I mean, where we will get the step voltage. This is my VDC. Okay, now the output of this is a step, and then we have L and C. Okay, we have L and C, and then we connect rectifier. Okay, and we connect rectifier. Okay, so we know that, and there is a resistive load. Okay, now you can see that, I mean, you can say that from here the load will be, I mean, the load seen will be a resistive nature, though it's not resistive pure, but since we are using diode and we are using resistive, then the voltage and the current at this point will be in same phase. I'm assuming that. So you can say that the load is RLC type of nature, and the damping factor will decide the output voltage wave shape. Okay, damping factor will decide the current, what type of current, because it depends on the nature of the load, whether it is under damped, over damped, or critically damped. Okay, that will decide the current build up, because here you will get the step wave, and then the current, that current will depend on the type of load and the damping factor of the load. Okay, so that's why the answer should be Bombay. That's why the answer should be Bombay. So in a series resonant converter, the load damping factor will decide the load damping factor of the, I mean, the damping factor of the load impedance will decide the output voltage wave shape. Okay, let's come to the next question, guys. Again, we have power electronics question. So let's come to the next question. Yes, the next question is, wait a minute. Okay, so the next question is on your screen, and you can see that which of the following switching technique is commonly opted in resonant converter. Okay, so in resonant converter, which switching techniques you use? Answer is Calcutta. It's just memory based question. Zero voltage switching or zero current switching. So answer is Calcutta. Let's move to the next question, guys. Let's move to the next question, and the next question on your screen is the function of static transfer switch in a multi-modular uninterruptible power supply. Okay, in UPS, generally we use a static transfer switch, and what this transfer switch does, it's like inverter in our houses. Whenever the supply comes, that will cut the inverter supply, and wherever the supply goes, it will turn on the UPS supply. Okay, so the answer is the function of static transfer switch in the multi-modular uninterruptible power supply UPS system is to change over the power supply to critical load from the UPS to power lines. That's correct. Okay, so we have a load, and it connect or disconnect. It used to change over the power supply to critical load from the UPS to power line. Okay, so that's the correct answer. So answer is Agra. Okay, let's move to the next question, guys. Let's move to the next question, and the next question on your screen is the static VR compensation is usually designed to operate. Actually, the static VR compensation is used for both for lagging and leading reactive power, but generally our load demand lagging reactive power. That's why the static VR should supply the leading reactive power. The static VR should operate at leading power factor. It means it should supply the lagging reactive power because the load demands it. So it should operate at leading power factor. Okay, so I think the answer is Bombay, leading power factor. But actually, you can use it at leading power factor or lagging power factor both. But in generally in practice, we require the lagging reactive power. It means this static VR should supply the lagging reactive power. Lagging reactive power means it should work like a capacitor. It means it should work on leading reactive power. Okay, let's come to the next question. Yes, the next question on your screen is transformer take advantage of high magnetic energy density of ferromagnetic material to allow the economical device design. However, the nonlinear nature of ferromagnetic material lead to introduction of harmonic in current or voltage. We know the BH curve, no? We know the BH curve. Generally, we operate the transformer at this point. Okay, at this point. Why we use the transformer at this point? The flux density should be at this point. Okay, and the H should be at this point. Okay, why it is so? Because if the flux density is higher, you need less core cross section area for some flux, because we know that phi is equal to B by A. Okay, so if you use high B, then you require less A. Okay, I hope it is clear, or maybe B dot A. This is B dot A. Excuse me. Phi is equal to B dot A. Okay. Now you can see that since this we require this phi is some, let's say, some value. We require some value of flux. If you require some value of flux, then B should be high and A should be small. If A is small, then you can say then the core cross section area is small. If the core cross section area is small, then there is, I mean, the saving of money. Okay, that's why this option is correct. The transformer take advantage of high magnetic energy density of the ferromagnetic material to allow the economical device design. Okay, it means your money is saved because the core cross section area is reduced, so small less core is required. Now because of this point, there is a it goes into the saturation region. If it is goes into the saturation region, obviously harmonics will be introduced in the system. Okay, so there will be introduction of harmonics in the current and the voltage. So you can say that this statement 1 is correct. Okay, now let's come to the statement 2. The nonlinear nature of the transformer magnetizing inductance can lead to transient inrush significantly greater than the rated value of the current upon energizing the transformer. That's again correct. It comes, the inrush current comes because of the nonlinear nature of the magnetization curve, okay, or the magnetizing inductance, you can say that. So statement 2 is again correct, but the statement 2 is not the correct explanation of this, because in the statement 2 he is discussing about inrush current, which has nothing to do with the harmonics. Okay, so because inrush current is a transient phenomena and harmonics is a steady state phenomena, so you can say that there is no link between these two statements, but both the statements are correct. That's why the answer should be Bombay. Okay, answer should be B. Okay, so these were the questions from power electronics and machines. I hope you enjoyed this session, and now Rathi sir will continue from this point, and I think analog electronics, sir.
हाँ सर, एनालॉग इलेक्ट्रॉनिक्स.
Okay.
So thank you Asu sir, and hello students. Now I am going to discuss some important numericals. So give me the response with me. Okay, now quickly I am going to discuss first question. One minute, give me 1 minute. Okay, now yes, this one. Okay guys, and that is the question. Yes, Dayal, and now give me the answer for this question. A silicon diode made half-wave rectifier produces a maximum value of load current as 20 milliampere through a resistance of 1 kilo ohm. What is the PIV of the diode? That is called peak inverse voltage of the diode, guys. Now in this question, this is the diode, here it is the RL, and this is the maximum current here, that is called maximum load current, and RL is given as 1 kilo ohm. Now when the diode is forward bias, it is given silicon diode. The drop will be what? 0.7 volt. We no idea about this battery. This is the plus, this is the minus. Let the maximum value is here Vm. Then what is the current here? I maximum is given by V maximum minus 0.7 divided by RL. So what is the value of Vm? Vm will become I maximum into RL plus 0.7. So what is the I maximum? It is given as 20 milliampere into 1 kilo ohm, milli kilo cancel plus 0.7. That is the value of the Vm is 20.7 volt. If the value of Vm is 20.7 volt means what? That is the PIV. So what is the PIV for the diode? Vm. So Vm is what? 20.7. That is the answer. Because when the diode is reverse biased, there will be the no current, and like this voltage is negative, the complete voltage will come across the diode, and that is called PIV, peak inverse voltage. That is the maximum voltage appearing across the diode when the diode is reverse biased. So कितने students का है ये answer? How many students got this answer? 20.7. Okay, so this is the answer for this one. Now next question. Okay. Then ripple factor for a half wave and full wave rectifier circuit respectively, right? And then please, student, mark that what a answer 0.48 and 1.21. This is a very, very easy question, and that is called what? Silly mistake. Now, ripple factor for what is written here? For half wave rectifier. First of all, you have to give the value for half wave rectifier, and then for full wave rectifier respectively. So for half wave rectifier, it is what? 1.21. And for full wave rectifier, it is what? 0.48. For full wave rectifier, it is 0.48. Then which answer is correct? Answer C is the correct one. That is wrong mark. That is called what? Silly mistake. Okay, so this is the ripple factor for half wave rectifier and full wave rectifier. Next question. I think you have given the answer. Now, again very easy question. Last year similar type of question. If a transistor has the value of the common base current gain, what is the common base current gain? Alpha. Alpha is equal to 0.98. Then what is the value of the common emitter current gain? For common emitter current gain, the beta. Alpha upon 1 minus alpha. 0.98 upon 1 minus 0.98. And you will get the answer 49. This is the 49 is the correct answer for this question. Very simple. Now that is the very, very easy questions from the analog. That is the 49. Now next one. Okay. So some students are confused with this. So what is the answer for this question, Dayal? What is your answer? And gate first student, what is your answer? Yes, Sai Prakash, Payas Kumari. Very good evening. Which one of the following is the correct circuit symbol representation of the P channel JFET? Right. In case of P channel JFET, this is we are using the N positive type. And this is we are using N positive type. And this region is what? P channel. And this is drain, and that is what? Source. And this is called gate terminal. Okay, this is the gate terminal. Now, the current, the source will provide the hole will move from source to drain, current will move from source to drain. So normally we are giving this type of symbol because it is written JFET, junction field effect transistor, and that's why this answer is not correct. These are not correct because it is for insulated gate field effect transistor. Insulated gate field effect transistor. So this is a double arrow, means there will be the SiO2 layer. This is for MOSFET. This is for MOSFET, and that's why the C and D are wrong. Now out of A and B. Now try to understand. First symbol for this is the current will flow from source to drain, right? And that is the arrow. Source to drain, or sometimes it is this is source, this is drain, P channel. This is source, this is drain. Third one, this is a junction, P N positive junction. Everyone tell me, in P N positive junction in a diode, the current will flow from what? For P side to what? N side. So it is outward from the gate terminal. So outward from the gate terminal means this is the source, drain and source, right? It is a symmetrical device. Outward from the gate terminal means this is the arrow. Now which answer is correct? Because it is a P and N positive junction, and that is the direction of the current outside the gate terminal, and that's why this is the G is the correct answer for this question, right? B for Bombay. Okay, next one. अच्छा कितने लोगों ने दिया जवाब? पयास कुमार, your answer is correct. Now B, Dayal. Okay then. अब आते हैं. Now this is the another one. Again, consider the following statements regarding FET amplifier configuration, field effect transistor. For a common source and common drain configuration, Rin is equal to R1 and R2, which can be selected to be the large, during the bias design. Tell me, this statement is right or wrong? This R1 parallel with R2, which can be selected to be large during the bias design. Why this R1 and R2 which can be selected to the large, right? Now, this is, try to understand this one. This is the MOSFET. Here we are giving the potential divider biasing. At this point, we have the very high input resistance. To maintain this high input resistance, we are connecting R1 and R2. That is what here it is the infinite resistance. So what is the R in here? Rin will be R1 parallel with R2. And we are connecting RS here and VS here. RS and VS. So actually, what is the advantage of the MOSFET? The input resistance is very high. But at this point, because of this R1 and R2, the Rin will become R1 parallel with R2 parallel with infinite. So what is the input resistance seen by the VS? R1 parallel with the R2. And that value should be high, right? It is in the range of what? Mega ohm. So this is in the range of mega ohm. Okay. So finally, this is the value R1 parallel with R2. It should be, which can be selected to be large during the bias design. This is what digital when we are doing the biasing. Okay. Next one, for the common drain configuration, the voltage gain is generally less than the unity or near unity. Common drain configuration. Common drain configuration is what similar to what common collector configuration. For common collector, what is the voltage gain? Nearly equal to 1 or less than 1. Again, the common drain, that is also called source follower. Again, this statement is right, that statement is right. For the common gate configuration, the current gain cannot be larger than unity. For common gate configuration, what is the input terminal? Drain, or this is the input terminal is what? Source, output terminal is drain. So what is the current will remain same, ID and ID. The same current, what is the IG? IG is 0. So what is the current gain? If this is the output terminal, this is the input terminal, the current will remain same. So what is the gain? Unity. For the common gate configuration, the current gain cannot be larger than unity. All three are correct. 1, 2 and 3 all are correct. 1, 2, 3. Okay, next one. Next question. And an amplifier has a bandwidth of 500 kilohertz and voltage gain of 100. What is the amount of negative feedback if the bandwidth is extended to what? 5 megahertz. So what is the bandwidth with feedback is given by bandwidth into 1 plus A beta, right? So this is given as 5 megahertz, 10 to the power 6 is equal to, old bandwidth is given as 500 kilohertz, 500 into 10 raised to power 3, 1 plus, you have to find the value of what is the amount of negative feedback? A. What is the basic gain? 100 into beta. From this formula, you can find the value of beta and it is around 0.09. You can check my calculation also, and that is the 10 minus 1, that is the 9 divided by 100, that is the value of beta, that is called feedback factor. Okay, next one to check the answer is what? C. An amplifier has an open loop voltage gain of 1000. If 10% negative voltage series feedback is used, what is the closed loop voltage gain? That is the question. Has an open loop voltage gain of 1000. 10%. Always remember, if beta is given in the percentage, if the beta is given in percentage, 10% means it is 0.1 actually, beta. Now what is the gain with feedback? AVF is equal to AV upon 1 plus beta AV. So this is 1000 upon 1 plus 0.1 into 1000. And it will become 1000 divided by 101. Now you can calculate 1000 divided by 101 is nearly equal to what? 9.9. Okay, and that is the answer for this one. Okay. Then now it is over. Rakesh sir. अब आ गए हैं राकेश सर, अब वो क्वेश्चन डिस्कस करेंगे फ्रॉम कंट्रोल सिस्टम.
सर कैसा है डबल ई का लेवल?
सर एनालॉग का तो लेवल बड़ा ही इजी था एंड दैट इज ऑल द क्वेश्चंस आर वेरी इजी, राइट? होप तो आप लोगों ने पूरे सॉल्व किए होंगे,
करेक्ट
है ना सर? कंट्रोल का क्या कहना है सर?
सर कंट्रोल भी आसान है, फैक्चुअल क्वेश्चन ज्यादा है डबल ई को. ओके,
और रिपीटेशन काफी है,
राइट? ओके, हाँ रिपीटेशन इलेक्ट्रॉनिक्स में खासकर बहुत ज्यादा थे,
बहुत ज्यादा.
डबल ई में भी कुछ है. चलिए गाइस देखते हैं फंडामेंटल क्वेश्चन. वेरी सिंपल. नेगेटिव फीडबैक सिस्टम हैज द फॉरवर्ड पाथ गेन ऑफ 18, forward path gain of 18 and feedback path gain of 0.15. what is the overall gain? So overall gain G upon 1 plus GH, right? सॉल्व कर लेना, अप्रोक्सीमेटली कैलकुलेशंस आप कर लेंगे, 4.86 आंसर आ जाएगा. दिस इज वन ऑफ द वेरी डायरेक्ट फॉर्मूला क्वेश्चन, G upon 1 plus GH, क्योंकि नेगेटिव फीडबैक है. ठीक है, चलो नेक्स्ट क्वेश्चन. Okay, so now this is something, this is all हार्दिक ये एडिट नहीं करके दिया है, ये गलत है पूरा, ठीक है. So guys, don't look into these things. This may not be correct. Okay, ये किसी student की copy है. Okay, consider the following conditions for second order system when subjected to unit step. With critical damping, there are no oscillations. Yes, sir. With no damping, the system output oscillates with constant frequency and variable amplitude. No, देखो, what is the undamped waveform? What is the undamped waveform? If I talk about unit step also, unit step, sorry, ये ले लेते हैं unit step reference, and this is 2. This is how undamped waveform look. Why? Okay, that is why we call it as pure oscillatory. It is a periodic waveform oscillating continuously between 0 and 2, right? So this is the constant amplitude, not the variable amplitude. And with overdamping, the output takes longer time to reach the steady state value. Yes, because it becomes slower. So correct statement are, which are not correct? Sorry, क्या पूछा है? Not correct. So which are the not correct? It is only 2. It is only 2. Correct answer is option number C. Correct answer is option number C. Okay, moving ahead to the next question. The next question. Okay, so now guys, don't mind this. I should not, they have not given me the correct version. इसको मत देखना. This is the student's answer. In the Nyquist stability criterion, the closed loop systems whose open loop frequency response dj omega hj omega loci as omega goes from 0 to infinity do not encircle. Do not encircle. No encirclement. N is 0. So n can be taken as p plus minus z plus, or whether contour is not given, or it could be z plus minus p plus, depending on the contour. Okay, depending on the contour. So what is the conclusion? That whether a p plus minus z plus and z plus minus p plus, it is equal to 0. That means z plus will be the p plus, right? Now nothing is mentioned about the open loop poles. If they mention that the open loop system is stable, then z plus will also be 0, right? So आगे हम कुछ भी यहाँ पे comment नहीं कर सकते. Actually, conceptually, we can't say anything here in this question. We can't say anything in this question conceptually. And let's move ahead to the next question here. Okay, let us move ahead to the next question. Okay, now it's a simple question. Which error time graph is relevant to the following integral mode controller output? Okay, this is the controller output which is increasing, right? And controller output, let's say the controller output is ut. This is nothing but the integral of the error signal. This is nothing but the integral of the error signal. Integral controller means it is going to integrate the error signal, and because of the integral of the error signal, अच्छा ये ramp की तरह increase हो रहा है. That means area under the up to this point to 0 है, तो area also 0, error signal 0. After this point the area is increasing. Logically, which option will match? Okay, it is going to be option number B. It is going to be option number B in that case. Okay, the area will keep on increasing as you move away, as you keep on increasing the time. More and more area will accumulate and the output will grow for the controller. Okay, so this is the controller output given. The correct answer is the option number B here. Okay, moving ahead to the next question. Yeah, this is simple. इसका आंसर भी स्टूडेंट ने सही मार्क किया है. So you have the transfer function k. Sorry, यहाँ लिख लेते हैं. You have the transfer function k into 1 plus j omega t. Right. Okay. Now definitely sorry, k upon 1 plus j omega t. Typo error है, इसको भी erase कर देते हैं. So what is the transfer function? K upon 1 plus j omega t. 1 upon x plus jy is a fourth quadrant term. Na? Why it is the fourth quadrant term? Because it is k 1 minus j omega t divided by 1 plus omega square t square. Rationalize किया तो, right? And when you take the face, imaginary part by real part, but k upon 1 plus omega square t square तो दोनों में common है. So when you want to take the face, it is going to be only tan inverse minus omega t upon 1. The constant term, the common term will cancel. That is why it is minus tan inverse omega t. Arc tan minus omega t. Fourth quadrant point it is. Okay, so correct answer is A. Moving ahead to the next question. Okay, 78. Which one of the following steps is correct while plotting an open loop Bode diagram? Okay, the transfer function of the transfer an open loop transfer function into constant frequency form. Why? No. For the low frequency asymptote, if there is only the proportional link, that means if it is only k, if GSHS is only k, one should plot a horizontal line with the amplitude minus 20 log k. No, it should be plus 20 log k. Na minus kaise bhaiya? It should be plus 20 log k. Okay. For the high frequency asymptote, okay, one should change the slope. Now, how high frequency you reach once you have crossed all the corner frequency? And what do you do at every corner frequency? You change the slope. right? So one should change the slope of the asymptote in every break frequency for every link. Yes, this is the correct procedure. This is the correct procedure. Okay, so C is the correct answer for this. Moving to the next question. Okay, next question क्या बोला है? For the closed loop transfer function as a part of necessary condition for stability of linear feedback system, the characteristic root must satisfy the following condition. Okay, no nil solution. Yes, if there are roots at origin, the system may be unstable or marginally stable. It cannot be stable. So this is a required condition. Yes, no conjugate pure complex roots. Okay. So, you know, if there are conjugate roots like x plus jy, ये pure imaginary नहीं बोला है, pure complex बोला है. So let's take x plus minus jy. So if you have pure complex roots, x plus minus jy, right, and if they are in the left half plane, then the system is stable. So ऐसी कोई condition नहीं होती कि there should not be any complex roots. There can be complex roots, but in the left half plane. All the real roots must be negative. Yeah, that is definitely true. They must be negative. This is true. So first and 3 is true. First and 3, ये student का answer जो भी है ये गलत है. First and 3 is the true. Option number C, 1 and 3. Okay, 1 and 3. 1 and 3. Okay, no nil solution मतलब no solution out origin. ये बताता हूँ ना. Suppose the transfer function is 1 by s and then you apply a step input. Suppose the transfer function is 1 by s, one pole at origin. Okay, and then you apply the step input 1 by s. So your answer is 1 by s square, and that is corresponding to ramp. And you all know that ramp will keep on increasing linearly. Although the input that you apply is a bounded finite step input, but the output with time will keep on increasing, and eventually the output is going to tend to infinity. That is why it is going to produce unbounded output, and that is why the system is unstable. Right? ठीक है, तो 1 correct है, नहीं चाहिए nil solution. This is the required condition. Which of them are the required condition? तो 1 and 3. Move करते हैं next question की तरफ. Here it is, number 80. Right? Now here there is a discrepancy. Here there is a discrepancy. ये question MSQ बन गया है actually. Now how this is the MSQ? Let us have a discussion of that. Right? This has turned out to be a sort of MSQ question. Okay, why? So देखो, the Routh array of an open loop transfer function of a unity negative feedback, सब कुछ सही given है, unity negative feedback is given, right? And the system is stable and unstable. तो यहाँ पे एक बात बोलूँगा that 32 minus 4k, if there is, this is plus, of course assuming k greater than 0, or even if you don't assume all options for k are positive, so this is also plus. So if 32 minus 4k is also positive, right? That means k less than 8, then the system is stable. Right. So of course for k greater than 8, system is unstable. So if you look into option number B and D, right, 6 and 6, system is stable. But 12 and 15, both पे system unstable होगा. So B and D is the correct answer. Now let us say what ESE ticks for it, because this is a MSQ question and MSQ is not a part of ESE, but the correct answer can be both B and D. Got this? Correct answer can be both B and D. And moving ahead to the next question, that is the number 81. Okay, so a very simple fundamental question. Consider the following table wherein 3 acceleration input signals are fed. Okay, R is the amplitude of the input, K is the open loop gain of the time constant type of the time constant form, standard form. Okay, what are the steady state errors in place of A, B and C? Now, whenever you apply, if it is a type 0 system, right, it will give a finite input. देखो यहाँ पे आना चाहिए finite, here it should be finite, and here it should be finite. It gives a finite error to type 0 system, finite input to step, finite error to step. Type 1 system, finite error to ramp. Type 2 system, finite error to the parabolic input, acceleration input. Okay. Now if the order of the input is increased, error will be infinity. This is infinity, so A will also be infinity. Right? If the order of the system is reduced, then the error is 0. ये बिल्कुल सही है. यहाँ पे infinity है, and this should be infinity. Okay. Then here again the order of the input is reduced. It should be 0, 0. That is already given. Now what you are required to find, ये देखना. अच्छा, C is required to be found. So C should be 0. A was required. So A should be infinity. Now B is the error due to ramp input for type 1 system. For type 1 system, right? What is the steady state error for unit ramp? It is given by 1 upon kV, and kV is equal to k in the time constant form, right? Okay, so for the input, for what input? For the input R into T, R is a constant. Unit ramp means only T, right? Okay, what is the steady state error? Steady state error, because of linearity, steady state error is also amplified by R. So R into 1 by K, R by K. So correct answer is A. Okay, जो B है, that is R by K. So correct answer here is A. Very fundamental question on steady state error. Okay, the correct answer is option number A. Moving ahead to the next question, that is the number 82. Which of the following is not a method to reduce the steady state error? Yes guys, increasing open loop gain will reduce the steady state error. Yes, so it is a method, not a method select करना है, right? Limiting system time मतलब okay, not allowing the type to increase. Okay, but we know that if the type increases, then only the error reduce. Na? So is it a type? Is it a way of reducing the error? No. If you want to reduce the errors, then type should increase. Type should not be limiting. Okay, type को limit या restrict नहीं करना है. So B, this is not a method to reduce the error. To reduce the error. Okay, to reduce the error, you should actually increase the system time. You should not limit the system type. Okay, next question. Number 83, fundamentals of root locus. The number of branches of root locus equal to number of poles. Yeah, because root locus is the locus of roots of characteristic equation. Okay, that is the poles of the control system. जितने poles होंगे उतनी branches होंगी. Yes, sir. The root locus is symmetric about the real axis. Yes, sir. The root locus approaches straight line as asymptotes. As the locus approaches infinity. Yes, for higher values of k, we approximate the root locus with asymptote. So this is also correct. So here all three are correct. Option number D. Here all three are correct. That is the option number D. Moving ahead to the next question. That is number 84. Consider the following visualization: lead, compensation, representation, frequency versus gain. Okay, कोई मतलब नहीं है. For what is the important thing here is you have a lead compensation. What? You have a lead compensation. Okay. Which of the above curves is or are that compensator? So now because it is a lead compensator, it has to be zero dominant. Na? It has to be zero dominant. It has to be zero dominant. The zero will come first, followed by a pole. Okay, followed by a pole. And when you draw the magnitude plot for such a system, it starts with zero or at some constant. Okay, then it should be increasing. Okay, and then it will become increasing because there is a zero dominance here. And then when the pole comes, okay, the slope which becomes 20, it is going to become zero again. The slope reduces. So correct is the waveform number B. Okay. B will satisfy the property of a lead compensator. The magnitude, the gain plot of a lead compensator. Clear? The gain plot of a lead compensator. Okay? Right. So guys, yeah, that's it from control system. I think around 11-12 questions we have discussed right now. Right. So that's it. And now Ashutosh sir will be joining for a few other questions. Right. Ashutosh sir will be joining for a few other questions. So you also keep telling and just try to solve the questions. How the levels, I think very simple. Many questions in control in electrical. You saw the factual fundamental questions. And now my favorite, all your favorite, Ashutosh sir is going to come up. Sir, what subject?
Material science.
Material science. Oh my God. Sir, how is material science system?
Sir, quite straightforward.
Quite straightforward. Almost all subjects we feel like
Either
that.
you know it or you don't know it.
How is the core in electrical this time? Machines,
Core is
power
easy.
system,
Core
easy.
is easy.
So more or less paper is easy for EE as well as for EC. So it is very easy. So Hardik is setting up the things. Should I do it? Slideshow. Thank you. So Ashutosh sir, the stage is all yours.
Thank you so much, sir. So guys, how are you feeling now? Everybody? So I will be taking up material science questions, and questions are quite straightforward. Some factual questions and some questions are little tricky also, because it is more of a subjective subject you can understand, because it is not numerical oriented, it is theory oriented. So let us start with the first question. Yes, he is saying the property of periodicity in a crystal structure is repeated in 3 dimensions. The positive ions occupy the corners of the cube. So the situation is something like this. So the corners of the cube being occupied by the positive ions, that is cations, and he is saying there are ions at the centers of the cubic faces. So the cubic faces is also having, just a moment. Yes. Ions like this. Okay. So you can understand all the 6 faces there are on. So this is going to be face centered. This is going to be face centered. So what is the answer? The answer is face centered. A. Face centered cubic crystal. Next one. Now he is asking the electrical conductivity depends upon what? So basically you can understand the electrical conductivity you can write as NQ mu. If you talk about the electrons only, if you talk about the holes also, then you will add the holes also. But generally, if we are talking about conductors, so you can understand we are talking about electrons only. So it depends on both the charge concentration and the mobility. So it is going to be the volume concentration of the electrons of the conductor and their mobility. So B is going to be the correct option. I think it is not visible, but you must understand this. Is it clear? Yes, they are. See the next question. The classical theory of diamagnetism of bonded electron in a free atom was elaborated by, it was a Langevin diamagnetism. It was a Langevin diamagnetism. So it basically says whenever the external magnetic field is present, then what happens inside the magnetic material, some magnetism is developed which is opposite to the external magnetic field, so that the material behaves as the diamagnetic material. You understand that for a diamagnetic material, if this is a diamagnetic material, and if you see the magnetic lines are going to be something like this. They will not penetrate into the material because of the diamagnetic property, and the magnetic field lines are going to be bypassed or repelled away. This is because of the magnetism inside the material which is opposite to the external field. Let us go to the next one. Which of the following is the process of heating a material to just below its melting point? So option is sintering. It's sintering. Option A. It is not visible, I think. Okay, but I hope if you have the question paper, you can understand it. In the sintering process, basically, we are going to form the material by compaction or by heating. But one important thing is that the temperature due to the heating should not be more than the melting temperature. It should be always less than the melting temperature. That is what is mentioned in the question, to just below its melting point. So A is the correct option. See the next question. Which of the following are the mixtures of the material used for the sliding contacts which appear between the trolley and the trolley cable in the electrical traction high braking power? This is basically called as pantograph. You must have seen, if you see the electric engine, okay, if you see the electric engine of the electric, if you see the engine of the train or the locomotive, you will see there is a curved shape device which is called as pantograph, which keeps the direct contact between the power line and the line which is giving supply to the apparatus or the motors in the traction system. So that is basically using silver, copper, lead with zinc and aluminium. So A is the correct option. This option was quite confusing because if you see, it is very close. The options are given very close. So, but if you go with the right answer, I think A is going to be the better answer comparatively. See the next question. Which one of the following is the element which exhibit antiferromagnetism? What is the property of antiferromagnetism? Here, the dipoles are going to be oriented anti-parallel to each other and their magnitude is same. Something like this. This property is called as antiferromagnetism. Because of this antiferromagnetism property, what happens? Spontaneous polarization is going to be zero. There is no spontaneous polarization. No spontaneous polarization means what? Sorry, magnetization. Magnetization. It means even when the external magnetic field is zero, When external magnetic field is 0, the magnetization is also 0 because it is going to be cancelled by anti-parallel magnetic dipoles. And it is represented or exhibited by chromium. Chromium is the correct material. Now, these type of questions you cannot expect with all the confidence. So, generally, most of the candidates are going to be confusing with these questions. So, don't worry about it because it is relative. What is difficult for you is going to be difficult for others also. Okay. See the next question. Electro-optic device that emit the radiations of the different colors are called as, so this is generally light emitting diode. Now, light emitting diode can be used to produce different colors because if you are using different material, so that you are getting different wavelengths, you get different colors. So, it is going to be light emitting diode. Next one. The phenomena where superconductivity in the material is suppressed by exceeding the maximum current the material can conduct and the maximum magnetic field it withstand critical field is called as. So this is quench because it cannot be sinter, it cannot be odd man out. You have to do this was easy question. It cannot be sinter, it cannot be stripes, it cannot be proximity effect. So the answer is quench. Is it clear, everybody? Yes, everybody. Which of the following corresponds to the variation of the rotation frequency of the electron when the external field is applied? This is called as Larmor frequency. This is called as Larmor frequency. This is called as Larmor frequency. Because when the external magnetic field is applied, the angular momentum of the orbiting electron is going to be disturbed or it is going to be changed. That is why there is one additional component in the orbiting frequency of the electron that is called as Larmor frequency. Is it clear, everybody? Now, this was the classical question. This was the classical question and I hope some of you must have done it correctly. The question says which one of the following agents is an intrinsic agent that influences conductivity in the electro-insulating material. Simply, it is insulating material. He is just trying to confuse you with the electro-insulating material. Now, you please understand, humidity is going to be the correct answer for this question. But definitely, the conductivity of the insulator is going to depend upon the nature of dielectric also. Depending upon the nature of dielectric also, conductivity may change, may differ. Depending upon the temperature also, pressure also, it may change. But what is the dominant factor? The dominant factor is humidity. You must take the example as, if you talk about the insulators for the overhead transmission lines, you must remember that in case of pollution or rainy season, the insulating property of the insulator is heavily subjugated, heavily reduced. So, insulator conductivity will depend heavily upon the humidity. So, this is going to be the correct answer. Everybody just tell me yes or no in the comment section. Are you able to follow this? Is it clear? Okay, so see this question. This question says that there was a sample material whose dimensions are given, volume is given basically. So the volume is 1.25 10 to the power minus 6 into 10 to the power minus 3 into 10 to the power minus 3. And he is saying the ion concentration is given by this volume density. Okay. So if you multiply this volume with this density, you will get the ion concentration. So multiply it with 10 to the power 25. I think it is 25. Please cross check it. And if you multiply the ion concentration with the charge of one ion, you will get the total charge, and this is the positive charge. So multiply this with 1.6 into 10 to the power minus 19. Now this is going to be the total positive charge because of the ions in the crystal. Now he is saying the rest of the crystal volume contains equal densities of electrons having the negative charge and the positive ions. Now the ions and the electron charge are going to be equally and opposite, and their density is also same. So they are going to neutralize each other. So what will be the net total charge? The net total charge is going to be only the charge because of these positive ions. So this is, if you solve it, you will be getting it 2 into 10 to the power minus 6 coulombs. Is it clear, everybody? Is it clear? Okay. Now this question belongs to power system. Okay, this question belongs to. There are two questions for power system. Now this question is about the circuit breaker. So let us read the statement and then understand. He is saying statement 1, and you have to find the incorrect statement. You have to find the incorrect statement. He is saying the arcing time of arc controlled circuit breaker varies considerably depending upon the breaking current. So definitely this is true. If the breaking current is going to be too high, then arcing time is going to be high. If the breaking current is too low, then it is going to be less easily it can be interrupted. So statement 1 is 100% correct. If statement 1 is 100% correct, it means it should not be your answer because he is asking the incorrect statement. So option A is 100% wrong. You have to choose the incorrect one. If you see the second statement talks about the air circuit breakers. Now air circuit breakers, their dielectric strength or the capacity of the medium, that is air, dielectric strength is less. So they are generally used for low voltage levels, not for higher voltage levels. And he is mentioning that they are also used for higher transmission levels. This is wrong. It means 2 must be your answer because 2 is incorrect. So where you can find 2? The only option is B. The only option is B. So accordingly you can see what is the correct answer. Is it clear, everybody? See the next question. Now this question talks about the HVDC. This question talks about the HVDC. Now you see, he is saying in HVDC transmission, we generally require the high power factor. High power factor is required. What is the reason? Please understand. There are 2 reasons. Number 1, if you go to the AC side of the HVDC, you will see for AC side you require reactive power compensation. If you go to the DC side, now DC side there is no actual requirement of reactive power compensation, but at the HVDC converter station, because of the presence of the converters or the inverters or the power electronic devices, you require reactive power support. For that purpose, we always want that our operating power factor should be high. Now for this, what is the conclusion? For a given current and voltage of the thyristor and transformers, the power rating of the converter is equal. This is actually wrong. This should be more. It should be more. Okay. Now statement 2 and 3 are correct. Statement 2 says the stress on the thyristor and damping circuit is going to be reduced because of the high power factor. This is correct. This is correct. For same power to be transmitted, the current rating of the system is reduced, and also the copper losses in the AC lines are going to be reduced because you are operating the system at a better power factor. So 1 is incorrect, 2 and 3 are correct. So D is the correct answer. Okay. So this is all from my side. And now after me, the next faculty is going to take up the other part of the questions. Everybody who is live with me, just can you quickly tell me in the comment section, how was your experience for the engineering services examination? And let me tell you one important thing, that this time question paper is easy, and at the same time the number of seats are good. Number of seats are significant this time. We will disclose it in the later part of our discussion, what is going to be the cutoff and how much score is going to be a safe score so that you can sail through to the mains examination. So Dayal, Payash, everybody, Gate, first student, everybody just tell me in the comment section, how was your experience? How was your paper? And how was your paper 1 also? And those candidates who are preparing for the next year, don't worry. I think engineering services is again going to become a very coveted professional career for engineers, because now the vacancies are going to be increasing time and again. This year we have seen significant increase in the vacancies in the engineering services examination. Next year also we are expecting more and more number of vacancies. So definitely the demotivated candidates who were thinking vacancies are very less, they should not be demotivated, because more number of vacancies are going to be coming in the future. So after me, once again, Ankit Joshi sir is going to rock the stage with his great problem solving skills, and he has been one great motivator and mentor to me and all of us. So, Angri Joshi sir, welcome.
Thank you, sir. Thanks for the compliments. So students, now you can see the questions once again from engineering mathematics. So engineering mathematics is the USP in electrical engineering paper. So if the eigenvalues of this matrix 5, -2, m and -6 are 3 and -4, then what is the value of m? So student, we have one very basic, very simple property, that the product of eigenvalues is equal to determinant. So determinant will be -30 plus twice m, -30 plus twice m. 5 into -6, -30 and minus plus twice m. Eigenvalues are 3 and -4, multiply them. So -12 will be the product. So twice m, yes, 30 is brought to the other side. 30 minus 12 is 18. So m will be 9. M will be 9. M will be 9. M will be 9. So option D will be the correct answer. Yes, let's move to the next question. So students, in this question, they have given you a function z as function of x plus ct, f of x plus ct, and another notation phi x minus ct. So students, what we have to do here, we have to find the value of del square z by del t square. Very simple. So students, first of all, I will differentiate this z with respect to x. Okay, we'll do that. So del z by del x, sorry, del z by del t, partial derivative of z with respect to t. Okay, we need derivative 2 times. So okay, del z by del t will be f dash x plus ct, and derivative of this argument once again will give you c. Then derivative of phi of x minus ct will be phi dash x minus ct, and derivative of this argument once again will give you minus c, derivative with respect to t. Remember this. Once again I am differentiating this, once again I am differentiating this with respect to t. So I will get del square z upon del t square. So double derivative of this. Okay, so you will get f double dash x plus ct, and again c will be there, so c into c will give you c square, and differentiate this with respect to t, you will get phi double dash x minus ct, and once again you are getting minus c, so minus c into minus c will give you c square. Okay, if you take c square common, or what you do, just take c square common. So what is the remaining part? Remaining part will be f double dash x plus ct, just a moment, and c square is out, so phi double dash x minus ct. So student, if you observe closely this function can be obtained by partially differentiating z 2 times with respect to x. It means del square z by del t square is my left hand side, c square, and this entire bracket can be replaced by del square z by del x square. So in this question they asked you the value of del square z by del t square, so which comes out as option B, c square del square z by del x square. Just have a look over this question. Let's move to the next. Yes, so students, this is quite lengthy question. So here you need to derive the Fourier series. You can check with the options also. So I have already worked out this Fourier series for you. So I will be giving you the Fourier series coefficients here. So just a moment. Yeah. So students, A naught, that is the average component. Just a moment. Yes, sir. So A naught, it is 1 by T, integration over 1 period, and f of x. Okay, f of x dx. It means you just need to calculate the area under this signal divided by the period. If you draw the plot of this signal, you will get the plot as, yes, in the interval 0 to pi it is x, and in the interval pi to 2 pi it is pi. So this is one period of the signal given. This is one period, and since it is periodic, this will be repeated. Okay. So all my dear students, when you calculate the area of that signal, area under that signal, divide by t. So what is t? T is nothing but period, that is 2 pi. You will get the answer as 3 pi by 4. 3 pi by 4. This is the DC component. So 3 pi by 4 is the DC component in all the components. So just go for the next coefficient, that is AN. Chali. So AN will be 2 by T, integration over 1 period, f of x cos n omega naught x. So what is omega naught? Omega naught is 1. See, period t is 2 pi, omega naught will be 2 pi by t, so that will be ultimately 1. So cos n omega naught x will give you cos nx. So ultimately this an is obtained as, yes, I have obtained this an, and this is valid only for the odd values. So my an is obtained as minus 2 by pi n square when n is odd. And it is 0 when n is even. Just you need to work out this integral. And when you calculate Bn, this Bn is this Bn is 2 by T, integration over 1 period, f of x and sin nx, because omega naught is 1. When you work out this integral, you will get Bn as minus 1 by n. Minus 1 by n. So student, we are having n equal to odd. For n equal to odd, the value is minus 2 by pi n square. The same can be implemented. The same can be implemented using this expression. See, I'll tell you. A naught is 3 pi by 4. Yes. Then we have Bn. Bn is minus 1 by n, and then sin. So Bn is minus 1 by n sin nx. Okay. And see this term. In this term, if you put, we need to substitute only the odd values of n. But here the summation is having continuous values from n equal to 1 to infinity. So if I put n equal to 1, I must get what I am getting, cos 2 minus 1, that will be cos x upon 2 minus 1, that is 1 square. When you put n equal to 2, you will get cos 4 minus 1, cos 3x upon 3 square. So option A is giving you the correct solution. Why not option B? Because option B is having this plus sign, but our Bn term is negative. Bn term is negative, minus 1 by n. So this will be our Bn. So option A will be the correct answer. Let's move to the next. Yes. So student, this is an integral question from complex numbers or complex variables. Here what you can do, you can expand this e raised to 1 by z. So let us say this f of z is, just a moment, this f of z is e raised to 1 by z. It is 1 plus, yes, it's expansion, 1 plus x upon factorial 1 plus x square upon factorial 2 and so on. Now, what is the residue of f of z at z equal to 0, that is at origin? That residue will be coefficient of z in 1 by z term. Coefficient of z in 1 by z term. So this will be nothing but 1. So we have got the residue by Cauchy's residue theorem. Cauchy's residue theorem. This integral is equal to 2 pi I sum of all the residues. So residue is nothing but 1. So my answer will be 2 pi I. 2 pi I. Option B will be the correct answer. Got it? Let's move to the next. Now see here. This is simple value based question. Function f of z is given twice iz plus 6z bar. What you can do? You can replace this z by x plus iy. Replace this z bar by x minus iy. That is, z and z bar are complex conjugates of each other. So students, our f of z, just a moment. F of z, Haji, this will be twice iz, z is x plus iy, and then we have 6z bar, so 6z bar means x minus iy. Now students, you can collect the values of x and collect the values of real and imaginary part. So 6x is the real part, then we have 2i into iy, that is minus 2y. This is the imaginary part, this is again the real part. Now imaginary part will be having I as the coefficient. So I into 2x minus 6y. And students, when you substitute this point, z equal to 1 by 2 plus 4i, it means x equal to 1 by 2 and y equal to 4. So you will be getting minus 5 minus 23i. So at this point, option C will be obtained. Got it? Let's move to the next. Yes. So students, this is again a question from transcendental and nonlinear equations. So you can solve this question using Newton-Raphson method. So according to Newton-Raphson method, we have the formula xn plus 1 equal to xn minus f of xn upon f dash xn. Okay. Now students, for the first iteration, you will put n equal to 0. You will get x naught minus f of x naught upon f dash x naught. And x naught I am taking as 2.7. As all these options are having 2.7 as the first digit. 2.7. So when you put x naught equal to 2.7, you have to first find out f of x naught and f dash x naught as well. So this is our f of x naught, this is our f of x, and ultimately f dash x will be obtained by taking the derivative of this. So derivative of x, sorry, x as it is, derivative of sin x will be cos x, then sin x as it is, derivative of x will be 1, and derivative of cos x will be minus sin x. So the two terms will cancel each other. This is your f dash x. Now students, when you put x naught and f of x naught and f dash x naught, what you will get? You will be getting 2.8023. I got some pre-calculated results. 2.8023. And in the second iteration, you will be putting n equal to 1. You will be getting x2 equal to x1 minus f of x1 upon f dash x1. x1 is 2.8023. So ultimately you will be getting 2.7498, I guess. 2.7984. 2.7984. 2.7984. Just have a look over this solution. Let's move to the next question. Yes. So students, this is a question from normal distribution, and they have given you the cumulative distribution function for this particular normal distribution. Cumulative distribution function. And we have seen such questions in our classes, that when you wish to find out the probability for x lying between 2 points A and B, what you need to do? Just you need to put upper limit b in the distribution function, that is CDF, f of b, and then the lower limit. The difference of this will be your answer. Now what they are asking for the probability for x, the probability that x exceeds 1. Okay, it means what? It means probability for x greater than 1. Obviously this will be probability for x lying between 1 to infinity. So all my dear students, this will be simply f of infinity minus f of 1. So f of infinity is always 1. F of infinity is always 1. And just we need to find out f of 1. So f of 1, this is the value of x which is available in this interval. Just put x equal to 1 here. So 1 minus e to the power minus 1. 1 minus e to the power minus 1. So ultimately you will be getting e to the power minus 1 as the answer. So e to the power minus 1 means option B will be my correct answer. Option B will be my correct answer. Is that clear? So students, now Sanjay Rathi sir.
I think you have enjoyed the session, and right guys, now we have solved number of questions here, and definitely ready for what mains exam. We are going to start some session for you, and I will give you the idea about how to write the answer in mains exam, right? And this is the just starting point of your journey for engineering services exam, right? Don't wait for the result, start your preparation for engineering services mains. एक दिन का ब्रेक ले लीजिएगा, 1-2 दिन एंजॉय कर लीजिए, राइट? और उसके बाद आप पूरी ताकत के साथ भिड़ जाइए. बहुत सारे एग्जाम्स आपके इंतजार कर रहे हैं, बार का भी एग्जाम आने वाला है, ओके? और अब जस्ट अभी रात में ही, आज ही रात में इसका कंप्लीट सॉल्यूशन पीडीएफ आप लोगों को अवेलेबल होगा, राइट, ऑन आवर ऐप, ऑन आवर ऑफिशियल वेबसाइट, दैट इज BYJU'S एग्जाम प्रेप गाइज. तो फटाफट आप सेशन लाइक कर लीजिए, सब्सक्राइब आवर चैनल एंड शेयर द लिंक ऑफ दिस सेशन. तो थैंक यू, राइट? बहुत ही जबरदस्त एफर्ट लगाया है हमारी टीम ने, बैकएंड पे भी काफी काम हो रहे हैं, और हम जल्द से जल्द आपको सॉल्यूशन प्रोवाइड करते हैं. ओके देन, थैंक यू एंड गुड नाइट गियर. थैंक यू.